Do you want to unleash the power of cloud computing and embark on a journey to digital transformation? Cloud Computing Basics is your gateway to harnessing the immense potential of this cutting-edge technology. By leveraging the cloud, you will propel your business to new heights of efficiency, scalability, and innovation. Cloud computing isn't just a buzzword, it's a game changer. With a seamless blend of flexibility and cost-effectiveness, the cloud revolutionizes the way businesses operate. Say goodbye to hefty infrastructure costs and hello to unlimited storage, on-demand resources, and lightning-fast processing speeds. Did you know that by 2023, the global public cloud market is projected to exceed a staggering $800 billion? That's right, the demand for cloud services is skyrocketing, and the opportunities are limitless for those with the right skills. But cloud computing is more than just numbers. It's a gateway to endless possibilities. From startups to multinational corporations, organizations of all sizes are embracing the cloud to accelerate their digital transformation journey, streamline operations, and enhance customer experiences. Now let's talk about the figures that matters. Cloud computing professionals are earning top dollar salaries, with entry-level positions commanding an impressive range of $60,000 to $100,000 per year. As you gain expertise and experience, you can unlock even more lucrative opportunities in this rapidly expanding field. So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below. Here are inspiring success stories from satisfied learners who have unlocked the full potential of cloud computing.
I will be permanently moving to Europe with my family soon. Simplilearn's course has helped me back a great job offer there with 60% salary hike. We cannot wait to start our new life in Finland. We are all so excited. Hey, I am Salahuddin Quadra and I am currently living in Algeria. I am working as Chief Information Technology Officer at Iris Tires. After working for 23 years in IT sector in Algeria, I felt that my career had become stagnant here. I wanted to experience what it's like to live in Europe, so I started applying to various jobs there. As someone who is responsible for making a decision, I wanted to upgrade my skills. I also realized that to get a new job, I needed to have a professional certification in cloud computing. So last year, I started the postgraduate program in cloud computing in association with Caltech from Simplilearn. It's not easy to get access to Caltech, but Simplilearn provided that with this course, I had the choice to study while I continued with my job. I learned technologies like AWS and Azure during the course. Luckily, my new employers were looking for someone who knew these technologies. I have just completed the course, but my new employers were aware that I was taking this course, and that is how I got this new job offer with 60% salary hike. In Finland, I will be leading the cloud computing unit of my new company. I am really excited, not just for myself, but for my family as well. I have 3 daughters. I think I will be able to help them with their higher studies in Europe. As a father, you always want to make decisions that have a positive impact on your children. As for me, I am going to live my dream now. I think dreams come true when you work hard to achieve them.
The future is in the cloud, and it's waiting for you to seize it. Unleash the magic of cloud computing and witness the floodgates open as your website attracts a tidal wave of organic traffic and enjoys unrivaled success in the digital realm.
Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You'll only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization.
So if you're ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
What is cloud computing? As we learn what is cloud computing, we will also be learning about how things were before cloud computing and benefits of cloud computing, different types of cloud computing available, and some of the famous companies that are using cloud computing and they're getting benefited out of it. We're going to learn all that. Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day, he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database, and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing, and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing. And he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. What is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Services and Microsoft Azure. Now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If you want an IT resource or a service now with cloud, it's available for me almost instantaneously, and it's ready for production almost the same time. Now this reduces the go live date, and the product and the service hit the market almost instantaneously compared to the legacy environment, and because of this the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all these 6 sort of stand out, categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private, is it public, or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now, in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications, and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on a subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the 4 models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resource managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. There are lots of famous well-known organizations around the world. They have moved or have migrated to the cloud environment. Pinterest is one company which is one of the world's largest visual bookmarking tool with more than 70 million monthly active users. Now, Pinterest was able to scale its business because it was all built on Amazon Web Services. With a company with less number of employees, Pinterest decided that they do not want to dedicate its staff time to manage a data center. Instead, Pinterest uses AWS, or they used AWS to manage their high-performance social application and store more than 8 billion objects and 400 terabytes of data in AWS cloud using a service called Amazon Simple Storage Service, or in short Amazon S3. And not only that, they are running 225,000 instance hours a month, and they run that on Amazon compute service called Amazon EC2 or Amazon Elastic Compute Cloud. Spotify is another company that got benefited using AWS. It's an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify needed a peculiar requirement. It needed a storage solution that could scale very quickly without incurring long lead times for upgrades. Long story short, Spotify used Amazon S3, which is Amazon Simple Storage Service, and Amazon S3 gave them the confidence in their ability and to expand their storage quickly while also providing high data durability. The third biggest company I want to mention is Netflix. It's the world's largest internet television network with more than 100 million members in more than 190 countries. Netflix uses Amazon Web Services for nearly all its computing and storage needs. Now that includes database, analytic, recommendation engines, video transcoding, and a lot more. Not only that, this company is planning to use AWS Lambda to build an automated or an rule-based self-managing infrastructure and replace some of their inefficient process to reduce the rate of errors and replace inefficient processes to reduce the rate of errors and save their valuable time. Expedia is another famous company that got benefited by using cloud. Expedia provides travel booking service through its flagship site called Expedia.com, and not only that, they also run 200 plus travel booking sites around the world. Expedia is all on AWS, and by using AWS, Expedia has become more resilient with an high scalable infrastructure and better cloud services because it had offloaded the IT management to the cloud provider itself, in this case AWS. And because of this, Expedia's developers have been able to innovate faster while saving the company millions and millions of dollars.
So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
We can categorize the different types of cloud computing based on two wide categories, one being a deployment model and the other one being service model. Let's talk about the deployment model first. Deployment model is categorized into three types. First one is public, and then private, and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. It'll be easy for me to explain, and also it'll be easy for you to understand if I walk you through this example. Consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resource that I use, and I pay for how long I use use it. If I use less, I pay less. If I use more, I pay more for that month. Simple. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here, I pay a huge amount upfront and it is all owned only by me. I do not pay for it in an hourly fashion, but completely and all upfront. The cost here is very huge. And thirdly, if I want the best of both types, like the comfort of the own car and still don't want to pay all upfront, otherwise want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in a hybrid environment, meaning if I already have a DC, I can integrate it with the cloud and use both the DCs, and that would become an hybrid environment. Alright, so that was good of an learning. Let's summarize the types of cloud based on deployment models. And as we know now about the public cloud is an cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players as cloud providers are AWS, Microsoft Azure, IBM's Blue Cloud, and Sun Cloud. And private cloud, now this cloud infrastructure is exclusively operated by a single organization. It can be managed by organizations or third party and may exist on premises or off premises, doesn't matter, but the point here is this is exclusively operated for a single organization. And some companies that provide private cloud are AWS and VMware. And hybrid cloud gives the best of both public and the private cloud. For example, the federal agencies, they opt for private clouds for storing and developing personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments. Now let's talk about different clouds based on the service model. If we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, or platform as a service, PaaS, or software as a service, SaaS. They sometimes are referred to as IaaS, PaaS, and SaaS. Now at this moment you could be like this guy thinking, Sam, I thought you're done categorizing the cloud. Now you're going to talk about 3 more categories? Which one should I pick? Well, let me explain. If all that you want is just a VM and you have all the expertise to install the software on top of it and make it work, then go for IaaS. If you only want a platform or an interface to program or an interface to upload a program and make it run, then pick PaaS. Or if all that you want is a finished product hosted in the cloud and be able to access it through the internet, then go for SaaS. Here you get a username and password for an application and you can begin to customize the application based on your needs. Alright, let's talk about IaaS in a bit more detail. IaaS, it gives basic computing infra. It's based on a pay for what you use model. And some of the cloud providers who are big players are AWS, Azure, and Google. And here the users generally will be IT admins. In PaaS, the provider gives you a platform or a runtime environment for developing, testing, and managing application. It's platform ready. You buy the platform, you upload your code, and you start working on it. And it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would use PaaS is software developers. And in SaaS, everything is managed by the vendor, be it the hardware or the software. It's managed by the vendor, and we pay for the service and we pay for it through a pay-as-you-go subscription model. And as you might have guessed, the end users here would be end customer itself. Alright, let's put together everything in the same page and compare and contrast the different types of service models. In this chart, it explains the difference between the 4 models, starting from on-premises to IaaS and then PaaS and SaaS. It is self-explanatory that the resources managed by us are huge in on-premises and little less in IaaS, and further less or reduced in PaaS, and nothing to manage when it comes to SaaS. Let me also explain the different types of cloud services through an example like this. Let's say that you have a crush on cake and you're planning to bake one yourself. Now let's look at the options you can have. You can make all the ingredients yourself, be it the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, the needed water, and the rest. You get an idea, right? Everything is yours, and that's on premises. All that you use is owned by you and nothing is managed by the vendor. The other options you can have is buy the ingredients and mix and bake the cake yourself. Now, this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service is a shared responsibility. The other options you still have on hand is simply pick a phone and order a cake. Now this is a lot simpler than the rest we discussed so far. It's simply picking the phone and ordering the cake and pay for it when it arrives. Simple. And when it reaches home, you will have to arrange the table, garnish the cake if that's needed, and then enjoy the cake. It's the same way with PaaS. Just get the platform in which you would run your code and upload your code and start running your application. Here you and the vendor still share the responsibility. You still have one more option left, that is simply go out and dine. This is a lot simpler, that it requires no effort from us at all. You buy the fully finished and garnished cake and pay for it and walk out. No responsibility on making the cake. It's the same way with SaaS. We buy the finished product and pay for the finished application.
So if you're ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
Now let's understand what do we mean by the cloud computing architecture. So this diagram represents the cloud computing architecture, where you can see there is a cloud infrastructure which we call as a front end. Front end means the infrastructure that is network facing, that is internet facing. And the back end is where actually the application, the services and the devices are, like storage, servers and all, along with the management and the security portals. So primarily the cloud computing architecture has two components. One is the front end and the other one is the back end. Now with respect to the architecture, the cloud computing architecture, as we discussed earlier, is divided into two parts, front end and the back end. It provides applications and the interfaces that are required for the cloud-based services. So front end would be anything which is facing the internet. For example, the websites that you deploy, they are front end because they are accessed by the public over the public network. These applications basically, such as web browser, Google Chrome and Internet Explorer, over which you can basically open up your web applications, your websites, and also it includes client and mobile devices along with some APIs. So this is with respect to the front end architecture. Now let's look into the furthermore concepts related to the front end. So in the front end, the cloud infrastructure consists of a hardware and the software components. That includes a data storage, server, virtualization software, etc. Also, it provides the GUI, or we call it as a graphical user interface, to the end users so that they can perform the respective task. So it's a GUI based access, and those who are not from the coding background or they don't have familiarity with the CLI, it is an advantage. Now let's understand the backend architecture. So the backend is basically, it manages all the programs that runs the application on the front end. So whatever is required to support the applications, for example, web applications which are running on a front end, would be available in the backend. It has the larger number of data storage systems and server. So it is basically, it comprises of the entire infrastructure of a cloud provider. And it can also be a software or it can be a platform as well. So based on the requirement, the application provides output to the end users in the backend. Also, it is one of the most important components in the cloud because it is, you can say, a backbone of a cloud computing architecture. And its task is to provide utility in the architecture. And the few services that are widely used among the end users are storage application, development environments, and the web services. In the backend, with respect to the storage, it maintains and manages any time of any amount of data over the internet. Some of the examples of storage services on the cloud are S3, which is called as a simple storage service, Oracle Cloud Storage, and Microsoft Azure Storage. The storage capacity varies depending upon the service providers available in the market. And also it allocates specific resources to a specific task. It handles functions of cloud environment. So this is with respect to the management in the backend architecture. The management in the backend architecture helps in the management of components like applications, task, service, security, data storage, and the cloud infrastructure. And in simple terms, it establishes coordination among the resources. Coming to the security aspect of a backend architecture, it is an integral part of a cloud infrastructure because since it mostly relies on the storage and the databases, so it has to be more secure. It helps in protecting cloud resources, system files, and the infrastructures. Also, it provides security to the cloud servers with virtual firewalls and results in the prevention data loss. Now, the different components of the cloud computing architecture, one is the hypervisor, second is the management software, the third one is the deployment software, fourth one is the network, fifth one is the cloud server, and you have the cloud storage. Now let's look into what we have with the hypervisor. Hypervisor, as the name suggests, is a virtual operating platform, and that is basically used by every user. It runs a separate virtual machine on the backend, which consists of a software and the hardware. Also, its main objective is to divide and allocate resources. So basically, the hypervisor is primarily used to virtualize the physical machines so that it can be shared across with many resources or many users. The management software, its responsibility is to manage and monitor the cloud operations. So all the operational tasks are basically done by the management software. It helps in improving the performance of the cloud since you can do the admin task as well. For example, high security, flexibility, full-time access, and the access given to other users who would be working on the cloud platform. The deployment software consists of all the mandatory installations and configurations that are required to run a cloud service. Every deployment of cloud service is performed using a deployment software. So it is primarily used for deploying the applications or a software. So that basically saves the time of a developer in terms of deploying their codes. Now, the three different models which can be deployed are the software as a service, which we call as a SaaS. So the software as a service means it hosts the software and manages the application of the end user. Example is Gmail. So Gmail is an example of a SaaS service where it acts as a mailing service, and the users just have to create their email accounts and start using the service. The PaaS is basically a platform as a service, and it helps to develop and build and deploy the applications and the software, primarily used by the coders. They can concentrate more on their development activities and less focus on the infrastructure part. Example is Microsoft Azure. And the infrastructure as a service, IaaS, is basically to provide services on pay-as-you-go pricing model. Coming to the component of a cloud computing architecture, that is network. So what is with respect to network? Why do we need a network? So it connects the front end and the back end together. So the network can be the internal private network of a cloud computing provider as well as the public network. And also it allows every user to access the cloud resources over the internet. It helps users to connect and customize the route and protocol. So let's say an admin wants a particular IPs to be blocked, so you can specify them and customize them in the route and the protocols. It is a virtual server which is hosted on the cloud computing architecture. So it is just like a virtual networking that is available on the cloud computing platform. It is highly flexible, secure, and cost effective, and it is basically you can say the backbone in terms of connecting multiple services together. The cloud storage is basically where every data is stored, and that can be accessed by a user from anywhere over the internet. Of course, it depends on how do you provide the access to it. It is scalable at runtime and it is automatically accessed. And the data can be modified and retrieved from the cloud storage over the internet itself.
For a better understanding, let's consider a scenario. Consider baking lasagna. You have 4 options. You can either bake it at home, or you can go to a restaurant to eat lasagna, or walk into an event and bake, or get it delivered to your doorstep. But how is this related to cloud computing? Well, let's take a look. We have 4 boxes. We have the traditional method, we have the infrastructure as a service, we have platform as a service, and we have software as a service. In the traditional method, everything is made at home and all the components are managed by us, that is kitchen, electricity, microwave, lasagna sheets, then toppings, meat, and cooking the lasagna. But when it comes to infrastructure as a service, the main kitchen appliances are managed by the vendor and the other things are managed by us. So basically the infrastructure is managed by the vendor. When we look at platform as a service, the infrastructure and the main ingredient for the software is managed by the vendor and the other things are managed by us. But when we look at software as a service, everything from the infrastructure till the end product is managed by the vendor. Now let's get into brief of all this. When we look at the traditional method, everything is done from the scratch, from choosing the right ingredients to the mode of preparation, and we have the full control of the toppings. This is similar to traditional method where all the hardware and software components are built by our choice of requirements. When we look at infrastructure as a service, we can say kitchen, electricity and microwave is the infrastructure, and this is where the code runs. The next step is to alter the software as per our requirements. When you look at platform as a service, it's similar to going to an event and baking. So you have the main ingredient, that is the lasagna sheet, and then you have all the appliances, that is kitchen, electricity and microwave, and the rest is managed by us. You can either put toppings, or you don't want to put meat, or you want it to be veg. It's all up to us. So the components are altered as per our requirements. Finally, in software as a service, the entire thing is modeled by the vendor. So this is where you just give in your requirements and you get the software delivered to you. It's basically where the deployment and framework of the project is already set. Now that we have a brief of all these services, let's dive deep into each one of them. First, we have infrastructure as a service. Infrastructure cloud provider gives a variety of infrastructures such as storage, services, network hardware, and so on. It also maintains and supports these infrastructures. Customers can access these resources over the internet. Next, let's look at the benefits of infrastructure as a service. So the first feature is that these resources can easily be scaled up and down. Next, the cost depends on the consumption. So basically it's a pay as you go pricing, and you pay for what you use. You pay for the services you use. A single piece of server can give out a lot of information to many users. And finally, the client has complete control over the architecture. Now, let's look at the pros of infrastructure as a service model. Firstly, it is highly flexible. This is because only the infrastructure is provided and the rest depends on the customer requirements. Next, like I said before, it is cost effective and you pay for what you use. It is easy to use as all the updates are deployed and all the hardware is deployed automatically. Management tasks are virtualized so that the other employees have time for other tasks. Now let's look at few of its cons. It is a multi-tenant architecture. Due to this, there is an issue with data security. When a new infrastructure is introduced, team training is required to learn all about this new infrastructure, and it consumes a lot of time. If in case the server crashes at the vendor side, the customers cannot access the data for a while and they would have to wait for quite a lot of time until the vendor fixes this issue. Now that we know what infrastructure as a service is, let's look at platform as a service. Platform as a service cloud computing platform is a developer programming platform which is used for the programmers to develop, test and run and manage the applications. A developer writes the applications and deploys it directly into this layer. All the infrastructure to run the applications will be over the internet. Let's look at the benefits now. Firstly, the resources can be scaled up and down based on the requirements of the user. Multiple users can access the same application. It allows for testing and hosting apps in the same environment. The web services and databases and servers are integrated into one. And finally, the teams can collaborate very easily. Next, let's look at the pros of PaaS. Firstly, the development process is quick and easy as it is a developer programming platform. It is cost efficient. You only pay for the services you use. When you use platform as a service, the coding is done by the developer before, so less coding is required, and then the migration to hybrid cloud is very easy. Next, let's look at few of the cons of platform as a service. Similar to IaaS, data security is an issue because it has a multi-tenant architecture. There's a compatibility issue with the existing infrastructure. PaaS is dependent on the vendor speed, reliability, and support. Now that we know about platform as a service, let's go ahead and dive deep into software as a service. In software as a service, everything is done by the vendors. The end users are only responsible to give their requirements, and everything is done by the providers. Now let's go ahead and look at its benefits. The installations and updations are done by the providers. Resources are scaled up and down based on the requirements of the users. The only requirement is that there has to be a strong network connectivity. And finally, the provider is responsible for everything. Now, let's go ahead and look at the pros of SaaS. Upgrades are automatic, firstly. Then next, it is again a pay-as-you-go model. It is easier to customize in SaaS rather than the other service models. It is accessible from any location. The only constraint is that you need to have a strong internet connectivity. Let's see the cons of SaaS. The provider has entire control. The end users only have the control of giving the requirements. There are only few solutions for software crashes. The devices should always be connected for better performance. Now that we've seen all the three models, let's see few of the companies providing these service models. The famous IaaS providers are Amazon Web Services, Rackspace, DigitalOcean, Linode, and Microsoft Azure. These are only a few. There are many more apart from these. Amazon offers many features such as auto-scaling, cloud monitoring, and load balancing features. When it comes to Rackspace, the cloud computing platform vendor focuses primarily on enterprise-level hosting services. When you look at famous PaaS providers, you have Heroku, Apache Stratos, OpenShift, Microsoft Azure, and many other providers. Going ahead, in SaaS providers, the most important one is Google Apps, then there's Salesforce, there is Cisco WebEx, there's Dropbox, and many more. Finally, let's look at the end users of the cloud computing service models. We can picture this as a pyramid. So in IaaS, the end users are system admins who are responsible for maintaining everything except the infrastructure. Then in PaaS, the end users are the developers who code on the platform provided by the vendors. In SaaS, the end users are the customers who give only the requirements and the software is built based on those requirements by the vendors.
Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS Services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off and he wanted to separate his cloud infrastructure or scale up his work requests and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell.
So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
Coming to the AWS services. So essentially AWS services are compute, storage, database, migration, networking and content delivery, developer tools, management tools, media services, machine learning, analytics, security identity and compliance, mobile services, application integration, AR and VR, which is augmented reality and virtual reality, customer engagement, business productivity, desktop and app streaming, Internet of Things, which is IoT. Now let's look into the compute service, which is one of the widely used service on the AWS. And what does the compute service do? These services help developers build, deploy, and scale an application in the cloud platform, that is EC2, Lambda, Elastic Container Service, Elastic Load Balancer, Lightsail, and Elastic Beanstalk. These are the services which lie in the compute service section only. One of the most widely used service within the compute section is EC2, which stands for Elastic Cloud Compute. It is a web service that allows developer to rent virtual machines and help to resize the compute capacity. So here what you can do is you can run the virtual machines and you have the privileges to select the type of operating system that you want should be running on your instances or on your virtual machines. And likewise, later you can customize as per your requirement. Lambda is a serverless compute service. It is also responsible to execute code for a specific application. So those who are from the development background, they can focus more on creation of a code. They don't have to create a server, manage it. Instead, they can use a Lambda where they can deploy their code directly onto the Lambda server. Then comes this storage service. Now, couple of storage services are S3 Glacier, EBS, which is Elastic Block Storage, Storage Gateway. Now, AWS provides web data storage service for archiving data. Also, its main advantage is disaster data recovery with high durability. Let's look into some of the essential storage services, and one of the most widely used storage services is S3, which stands for Simple storage service. In the simple storage service, what you need to do is you have to create a bucket, and in that bucket you have to put the files in it. So S3 gives open cloud-based storage service, which is utilized for online data backup. Then comes the EBS, which is an elastic block storage. Now you can understand EBS as a virtual hard drive also, which attaches with the EC2, and it provides high availability storage volume for persistent data. It is mainly used by Amazon EC2 instances. Then you have the database services. AWS Database Domain Service offers cost-efficient, highly secure and scalable database instances in the cloud. And some of the database services are RDS, which is a relational database service, DynamoDB, the non-relational or NoSQL or NoSQL database service, Elasticache, and Amazon Redshift. Now, one of the essential database service is the DynamoDB. It is a flexible NoSQL database service which offers fast and reliable performance with no scalability issues. It is fast, reliable, highly scalable, and suitable for small scale applications like mobile applications, gaming applications, or anything with respect to the Internet of Things devices. There, the DynamoDB is most widely used or suitable. Then comes the relational database service, that is the RDS, which is a structured database service. It is a managed distributed relational database cloud service that helps developers to operate and scale database in a simple manner. So RDS has different vendors platform with respect to the database usage, and that includes the PostgreSQL, MySQL, then you have Oracle, Microsoft or MS SQL, and they have their own customized database as well, that is called as the Amazon Aurora. Along with that, they have a Maria database or MariaDB as well. So these are a couple of vendors that give their database engines that you can use on the RDS. Now coming to the networking services, it offers a highly secure cloud platform and helps in connecting your physical network to your private virtual network with high transfer speed. Now, some of the services in the networking and content delivery are VPC, which is a virtual private cloud, a very important service in order to make your applications or services more secure. Route 53, which is a DNS mapping service. Direct Connect, which directly connects with the AWS services and with your data centers. And the CloudFront, that is basically a content delivery service. Now coming to the VPC or a virtual private cloud, it helps a developer to deploy AWS resources such as Amazon EC2 instances in a private virtual cloud, so that you can actually make your EC2 isolated or make it more secure, and even you can make it for a public access also. Depends on the administrator that how they want to customize it. So the complete control of a VPC and its networking is with the admins. Then comes the Route 53 service. It is a web service with highly available domain name system or the DNS that helps user to route software by translating text into IP address, and that is why it is called as a DNS mapping service. And that helps you to use your domains or the external domains pointed to the AWS services in case if you use AWS for hosting your websites or the applications. Note, DNS translates text into the IP address. Now coming to the developer tool services, it helps a user build, deploy and run an application source code automatically. It also updates the server and instance on the workload. So first is the CodeStar, Code Build, Code Deploy, Code Pipeline. So CodeStar, it is a service designed to manage application development at a single place. Here, developers can quickly develop, build and deploy applications on AWS. So all the managed app development can be done with the CodeStar. Code Build removes the hassle of managing physical servers and helps developer build and test code with continuous scaling. So security, identity and compliance services helps in monitoring a safe environment for your AWS resources. by providing limited access to specific users. So in case, let's assume that you have to give an access to someone but with limited privileges, you can primarily use IAM in that case. And if you want to make your applications or deployments more secure, then you can use these services like KMS, IAM, Cognito, WAF, which acts as a firewall. Now, the IAM service, which is the Identity Access Management, is a framework that helps in maintaining access to AWS services in a secure way. So what happens is that the admin who has the complete access of the AWS console provide access to users, and there can be different users, and they would have the privilege accesses defined by the admin. So what type of permissions the admin gives them, they would have those limited access on the AWS console. KMS enables users to create and manage the encryption keys that are used for encrypting data. Coming to management tool services, with the help of management tools, using this service, an individual can optimize costs, minimize risk, and automate all the resources running on the AWS infrastructure efficiently. So with the management tools, you can monitor the resources application, its tools, and the utilizations. And along with that, you can scale up, scale down the resources likewise. With the help of the management tools, you can also do the auditing task. So one of the essential service in the management tool service is the CloudWatch. It is a monitoring tool for AWS resources and customer applications running on AWS platform. So let's assume that you have used EC2, DynamoDB, S3, RDS, and you want to monitor those resources. You can use the CloudWatch that can give you the results. Coming to the CloudFormation, this service helps you in monitoring all your AWS resources at one place so that you can spend minimum time in managing those resources and maximum time on developing the application. So with the help of the CloudFormation, you can deploy the entire solution with the help of creation of a template. You just need to create one template and you have to deploy it. The rest of the things will be done by the AWS, and hence it is a kind of an automation task only. Now let's look into the demo of some of the essential services. So we'll start with the EC2, and I have already logged in into my AWS account. So where exactly you can find the EC2? Just click on the services. Under the compute section, you can find the EC2. EC2 stands for Elastic Cloud Compute Service, primarily used for creating the virtual machines. So I'll click on this service, and quickly I'll show you how the virtual machine is created and how we can basically access it. So I would be creating one virtual machine or an instance with the Windows operating system. So here you can see there are 3 instances which are already running. Let me create another one. So you have to click on Launch Instances, and here you have to select some configuration details. So most of the configuration details I'll be taking as default, and wherever it is necessary, I'll be making the changes. So first of all, you have to select the operating system in the form of AMI, and I would be looking for Windows 2016, and then you have to select the type of instance with respect to the CPUs, number of CPUs, and the memory capacity. So I'll go with T2.micro, which is a free tier eligible instance. In the configure instance details, the rest of the things we'll keep it as default as of now. Click on Add Storage. This is basically the virtual hard drive, or the EBS, the Elastic Block Storage, that is attached with the EC2 instance. So primarily it is giving us 30 GB of space without any additional cost. We can leave the tags as blank. Click on Configure Security Groups, and here you can see that the RDP port is by default open, which will actually allow us to RDP, or to have a remote connectivity of our instance. click on review and launch. Now to give an authentication or to provide an authentication, we should have a key pair with us so that the AWS can understand or can tally the key pair and give us the access. So I already have a key pair created. What I'll do is I'll create a new key pair for this instance and put a random name. Let's say I put it something like demo. Download the key pair and make sure that you keep your key pair in a safe and secure place. Click on launch instances. Now you will see that there is an instance ID that has been created, which is a number, alphanumeric number that is randomly given by the AWS. You can name your instances. So let's say we name our instance as Windows 2016. Click on save. And the AWS deploys our instance on a respective infrastructure. It gives us the IP addresses, the public IP and the private IP, which is an internal IP. And we have to access the instance from the public IP only. So now to access that instance, we have to open up the RDP, put the public IP, click on connect, and when it asks you for the authentication, you put a username as administrator and the password you have to generate by providing the key. So click on connect and then you have to click on RDP client. Here you have to get a password. So click on get password, browse, and when you click on browse you have to provide demo.pem file. So it should be in the download section here itself. Just provide that key pair and it is going to give you the password in the encrypted format. Decrypt your password, copy that, and then provide those details to the RDP client. Click on OK, and now it should allow you to log into the instance. Let's wait for the windows to appear. So here you can see that we have logged in into the Windows instance. The Windows 2016 screen is available in front of us.
If getting your learning started is half the battle, what if you could do that for free? Visit ScaleUp by Simplilearn. Click on the link in the description to know more.
In this particular demonstration, I would be explaining you about how to use a storage service, specifically the S3 service, which is most widely used service under the storage section. Now the S3 stands for Simple Storage Service, primarily used for storing the objects and the files. And what we need to do is we just have to click on the S3 service under the storage section. So when you click on S3 service, you have to create the buckets inside the S3. And the buckets are the places where you keep your folders or you upload the files that are available on your systems. So here if you'll notice that the S3 service is a global service. That means it is irrespective of the region. And the buckets when you create, they are created in a specific region. Now what is the benefit? The benefit is that if you create a bucket in different regions, all those buckets in different regions can be viewed from a single dashboard. And you don't have to change the region again and again to view the S3 buckets. So what you need to do is you have to click on create bucket, and here you have to specify the name of the bucket. So let's say I put something like demo AWS, and that's the bucket name I am going to select. Now make sure that the bucket name starts with a lowercase and it should be always unique. Now why it should be unique? Because since S3 is a global service, so it may be that somebody else could be using the name that you have provided. So it should be always unique, otherwise it will not be allocated. Now you have to select a region, and that would be, let's say I go with the Ohio region. And in the bucket settings, you can basically change and configure these settings according to your requirement. By default, when you create a bucket, it blocks all the public access from the bucket. So when you have all public access blocked, no object can be viewed from the S3 bucket from a public network or by anyone else. And hence, in order to view the objects or the files in the bucket, you have to unblock or uncheck this option, so that first of all you make the bucket accessible from the public network. Likewise, you can customize as per the requirement, and then click on acknowledgement. The rest of the things will keep it as default, and click on create bucket. Now it says that the bucket with the same name already exists, so that means it is not a unique name. Somebody else might have been using this name. So I'll try to keep it more unique, and I'll try to assign some number. So let's say I put something like 987, and it says it is already existed. Let's say 9876, and then click on create bucket. Now if it creates a bucket, that means we have been allocated with that bucket name. So let's wait for a minute to get that bucket created. So that happens quickly, and you can see there are a couple of buckets already created here, and these buckets can be viewed in a single dashboard. So some of the buckets are in Mumbai region, some of the buckets are in Ohio region, but they are available in the same or a single dashboard. So I'll open up the bucket that I have recently created, and I'll try to upload some documents. Now what you can do is you can create a folder also inside the S3, and when you create a folder, you can upload the objects accordingly. Otherwise, you can directly also upload the objects. So click on upload, and we will upload any random file from my system onto the S bucket. So I'll basically file, and then click on upload. Now it is uploading my object from my system onto the S3 bucket, and now it has successfully done. So it says the message is successful. Now in order to validate, I will click on the bucket from the S3 service and view this object. Now you can see here is my bucket. So I'll just open up this bucket, and these DNS records.csv file is available with us. Now the S3 is not only limited till storing the objects or the files. It has many other functionalities and the features also. Like you can enable versioning, you can host a static website on the S3. Along with that, you can have a cross-region replication enabled, so that you can have high availability of your objects, or you can have a redundancy of your critical objects in different regions. So likewise, there are more features that would be covered up in the detail section of an S3 service. Now coming to another section of the essential services, that is the database. Now here you can see I have a database section in the AWS, and it has multiple services within it. The RDS is there, DynamoDB is there, Elastic Cache, and the other database services are there. So I would be showing a demo on the DynamoDB, which is a NoSQL database. Now, when we say it is a NoSQL database, that means it is a non-relational database service where we can create a database table directly from the web console. We don't require a separate database engine like in the case of RDS. And in the tables, you can insert the values and view those values directly from the AWS dashboard itself. So it says Amazon DynamoDB is a fast and flexible NoSQL database service primarily suitable for IoT and web gaming and other mobile applications. So what you need to do is, it is a straightforward database service which can be accessed while creating a table itself, and it's a compute based database service. That is the reason that it is more fast. So click on create table, and what you need to do is you just have to put a table name. So I'll just put something like test, and in the partition keys, so these partition keys are unique entities. So what you need to do is you have to specify a partition key. So I'll put something like ID, and the string, instead of string, I'll use a number. Likewise, I can add sort keys also. Let's say I put a name, and the name should be in the string format. Now these are the unique entries. These are the fixed entries in the table. And after that, we are going to put the attributes, and in the attributes, the data will be inserted. So what you need to do is, rest of the things we'll keep it as default as of now. Click on create. And here you can see the table has been created. The test table has been created. Now if I click on the items, so you would see that it has the sort keys available, the ID and the sort key associated with that, that is the name. But it does not have any entry because we have not added any value or the attributes. So how we can add or insert the values in this table? That can be done many ways. You can enter manually. You can use the help of CLI to enter the large chunk of data directly, upload it onto the DynamoDB table, and also you can use the APIs also in order to insert the data inside the table. So what you will do is, we will click on create item, and in the ID we will put some value. Let's say number 1 string. Let's say we put something like we will go with a random name. So instead of putting any name, we'll put a value like ABCD. That should be fine. And then we will insert some attributes. So let's say I put string as rank, and I'll put something like rank 2, and then click on save. So here you will see, just refresh the database table, close it and open it up again. Click on the items. Now here you can see the ID 1, name is ABCD, got the rank 2. Likewise, you can click on create items. Let's say the serial number or the ID 2. Name, let's say we put something like, we can go with XYZ, any random thing. Put it up as number rank. And let's say this particular value got a rank 3. Likewise, you can add some more items. String, let's say you put something like HJK, and you put a rank, let's say it's a rank number 1 holder, rank 1 holder, right? So likewise, this is just an example. Likewise, you can add the attributes as per your need, and the table can be filtered out based on the attributes also. So if you have to search some values in the DynamoDB table, so you can always use filters to basically search the values inside the table. Apart from that, the DynamoDB table has a lot of other functionalities. It can be basically, you can have a backup of a table created in the DynamoDB table, in the Dynamo database, and then you can retrieve or recover the data by restoring the backups from the DynamoDB. This database can be created in the cluster format also. So these are a couple of features that you can use with the DynamoDB. Now let's move into the next section. Now coming to the networking services, so there are some of the networking services which are very useful, and that includes a VPC, which is a virtual private cloud, CloudFront, Route 53 API gateway, etc. Now I will basically demonstrate about the Route 53 service in this demo. So in the Route 53 is basically a DNS mapping service. So what you can do is, let's assume that you are hosting any web application on the server, and you want to route the domain traffic onto those servers. You need to have the help of Route 53 to do that. So what you need to do is, you just have to click on Route 53 service. And from this service, you can register your domains also. Otherwise, if you have domains purchased from any external site, you can point them to the Route 53 name servers also. So first of all, in the Route 53, you have to create a hosted zone. So there is already one hosted zone all created. Now, when you create a hosted zone, you have to specify the domain name. So let me show you. I have one dummy domain. This is the domain that has been defined. So what you have to do is when you click on create hosted zone, you have to put a domain. Here you can see example.com. Likewise, you have to put your own domain and click on the public hosted zone. Click on create hosted zone and it is going to give you 4 name servers. Now those 4 name servers have to be updated on the platform from where you have purchased the domain. So that is mandatory in order to route the traffic to the Route 53 service, right? So here you can see I already have a hosted zone created for a domain and it has given me 4 name servers. These are the name servers and these name servers have been updated in a record set from where the domain has been purchased, right? Once it is done, then you have to route the domain traffic to a server. So what you have to do is you have to click on create record, and in the create record you have to specify the IP address, or you can use the alias also, where the traffic should be routed to, where your application is hosted at. So ideally it is a server details, and it exists with certain policies also. So you can see some view existing records. So here you can see this particular domain is routed to a DNS value which is hosted in the Elastic Beanstalk. Instead of that, you can put an IP address of the EC2 instance also. You can use the S3 URL also. You can use the CloudFront URL also. So likewise, what would happen is that the domain traffic will be routed to the server where actually the application or a web application is hosted at. Now, I'm using a routing policy as simple routing policy. That means all the traffic should be routed to that particular domain. Whereas there are other routing policies also in the Route 53 that includes the weighted routing policy, which acts as a kind of a load balancing, geolocation routing policy, multi-value answer routing policy, and then you have a redundancy based routing policy, which is a failover one. So likewise, you can select as per your requirement. So what you need to do is you just have to click on create records. You have to specify, you have the domain, so you have to specify any particular info you want to put before the domain. Otherwise you can leave it as blank. And in the record type, let's assume that you are using an IP address of a server where your web application is hosted at. So you can basically use A routes traffic to an IPv4 address and put an IP address. Make sure that you put a public IP address or the Elastic IP address attached to your instance. In case if you are not using any particular IP address or the URL, you can use the alias also. So likewise, the records can be created. Along with that, the Route 53 service is used for domain verifications also. Like if you want the email services onto your web application, then you can basically verify your domain directly from the Route 53 service. You can get the verification done for the SSL certificate creation. For that also the records will be directly created from the Route 53 service because it is actually managing or hosting your domain. Now with respect to the security services, the most widely used service is the IAM, which is Identity Access Management. That lies under security, identity and compliance. So from the IAM you can create the users whom you want to give an access to your AWS console. You can create groups and you can add multiple users in that group, give them the permissions. You can create the roles also so that multiple services can interact or integrate it together. So how the IAM is used, click on the IAM service and I'll show you how a particular user can be created and how the user is basically uses the credentials to access the AWS console. Now the IAM dashboard is open, and when you open up the IAM dashboard, it gives you the URL. So this is the URL through which the user has to actually access the AWS console by providing the user credentials. Now how the users are created, just click on the users and here you just have to click on add user. So I'll create one sample user. Let's say I put something like sample user. And what type of an access you want to give that particular user? Do you want to give a programmatic access, which is primarily the CLI access, or you want to give the AWS Management Console? So right now we'll go with the AWS Management Console access. Now, do you want an auto generation of the password or do you want to customize the password? So let's assume that we customize the password. So put any value. Make sure the password meets all the criterias, and then click on next permissions. Now, what kind of permissions you want to give to that user? Let's assume that you want to give an access of a particular service only to that user. So you have to actually search a policy for that particular service that can be given an access to a user. Otherwise, if you want to give an admin policy or the admin access to that user, you can search an admin policy there. So the permissions are important, otherwise the user would not have privileges to access the AWS console. So we'll attach the existing policies directly. So click on it. And here, let's assume that I want to give an admin access to that user. So I'll just click on the admin access. Now, to a particular user, you can give multiple policies also. It is not necessary that you have to give only a single policy. So you can provide a multiple policies to the users also. Now click on next tags. Let's make the tags blank. Click on review and create a user. Now you'll see that our sample user would be created, and to access the console, we'll just copy this URL which has the account information as well, that is the account number. So copy the link, or you can copy the complete URL. Log out from the root account. And then paste the URL that was copied from the console. And then we have to give the user credentials. So we'll put sample user as the username and the password that we provided while creating the user. Click on sign in, and if it is correct, then it should allow us to log in into the AWS console while asking the password change. So we'll change the password. Confirm password change. And now it should allow us to log in into the root account's AWS console with the admin privileges. Now the next service is the monitoring services, and under the monitoring services, primarily the CloudWatch, the CloudTrail, the CloudFormation, these are some of the services that are most widely used. Now the CloudWatch is a service which is primarily used for monitoring the metrics, primarily of the servers. Like for example, if you create an EC2 instance and you want to basically watch out for the metrics associated with the CPU utilization or the storage utilization, the network in, network out, all those information you can get it from the CloudWatch. Now CloudWatch is not only related to monitoring the metrics, it can generate the alarms also, and here you can get the events also generated, which or the events that can be created which can trigger the Lambda function as well. So what you have to do is you just have to click on a dashboard. So monitoring metrics are viewed with the help of the CloudWatch. So first of all, you have to create a dashboard. Now you have to put a dashboard name. Let's say I put something like monitoring EC2. Click on create dashboard. Now how do you want the reports to be published? You have to actually select a widget. I want that, okay, the report should be visible in the numeric form. So I'll select a number. Now click on the dashboard that was created, and let's again add the widget. And here we'll select the metrics primarily for the EC2 per instance metrics. So we have one single instance running. Now there are 14 metrics available for that particular instance. Now I would be looking for the CPU utilization for this particular instance. So I'll just select for the CPU utilization, and it is going to give me some information about what is the current CPU utilization of that particular instance. So that is somewhere around 29.3%. the CPU utilization has been done for the single instance that is running in my EC2 dashboard. So likewise, you can add some more metrics and view them in this particular dashboard, and the CloudWatch will keep on publishing the data at a refresh interval of 5 minutes. That is the default value.
So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now, resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure Services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure Services. Now, Azure Services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now, these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have Express Route. Now, with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have Virtual Network. Now with Virtual Network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored. Let's talk about Azure Services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want. And the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have Express Route. With Express Route, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency, it increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. domain name service or Azure DNS can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have virtual network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have Data Lake Storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now all the data that is within the Blob Storage is unstructured data. Now it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have Queue Storage. Now with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue Storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have File Storage. Now with File Storage, you can perform file sharing with the help of the SMB protocol or the Server Message Block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have Table Storage. With Table Storage, you can deploy semi-structured datasets and an NoSQL key value store. Now this is used for creating applications which have a flexible data schema, and also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that, and by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have Logic Apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway, and you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now SQL database is also used extensively in migrating workloads to the cloud and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now this is a globally distributed multi-model database service. Now what this means is that with this you can create applications which support NoSQL. It provides a high-grade security system, has high availability and low latency. Now this is usually used in situations where you have a diverse and highly unpredictable workload. Now let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it.
So if you're ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
Let's understand why Google Cloud Platform. So Google Cloud Platform is popular for many reasons. Now let us see few of most important reasons why it stands out. When you talk about pricing is one of the significant factors that make Google Cloud stand out among the other cloud providers. It offers a monthly pricing plan, which is billed according to monthly usage. And when we talk about billing here, the billing can be in hours, it can be in minutes, and it can also be in seconds. There are different options when you talk about your pricing, which can be found from your Google Cloud webpage. Now, pricing could be based on preemptive machines. Pricing could be based on reserved instances or reserved resources. I'll show you the link where you can find more details on pricing part of it. So Google Cloud really has various pricing options which help customers in their different requirements, whether they would go for any of the service models such as infrastructure as a service, platform as a service, or even software as a service. One more attractive thing about Google Cloud pricing is that it provides committed use discounts. For example, under this scheme, you can purchase a specific amount of virtual CPU cores and memory for up to 57% discount off regular prices if you commit usage for either 1 or 3 years. Now, this is just one option. There are various such options which you can learn about from the Google Cloud's page, and that really suits different customers for their different requirements. Now, when we talk about speed, we don't need to really challenge this aspect when it comes to Google services. So Google provides its Google Cloud and Google App customer speed up to 10 terabytes because of its faster cable system. There are different kind of machines which can be used if you're talking about computation, if you're talking about memory hungry applications, or even storage intensive workloads. All in all, speed is one of the defining characteristics of Google Cloud services. The cable has connections over US West Coast, main cities in Japan, and even major hubs in Asia. This speed enhances performances and leads to customer satisfaction. Now, when we talk about customers, any or every customer would prefer to have low latency, high throughput based services. They would want to use higher speeds to process their data in as less time as possible. Google provides a low latency network infrastructure. In fact, you can say that when you are using Google Cloud services, you are using the services from the same infrastructure which Google uses for its popular services such as Google Search or even YouTube, which is one of the second largest repository which can be accessed for videos. Now, when we talk about big data is data which is very complex, has a lot of other characteristics such as your volume, you have velocity, you have variety, you have veracity, validity, volatility, virality, and so on. So if an organization is working on big data, Google Cloud can be a better choice because Google has many innovative tools for cloud warehousing, for example, such as BigQuery, and even real-time data processing tools such as Dataflow. BigQuery is a data warehouse that allows massive processing of data at high speeds, basically working on your structured data. Google also has launched some new machine learning from artificial intelligence tools. Now, there are various other services which we can use from Google Cloud Platform. But let's understand what is Google Cloud Platform and what are some of the services. Even the services which are not listed here can be found in your console from Google Cloud. So what is Google Cloud Platform? GCP. It is a set of cloud computing services provided by Google that runs on the same infrastructure, as I mentioned, that Google uses for its end user products like YouTube, Gmail, and even Google Search. The various set of services offered by Google Cloud Platform are, so you have services which are specific to computing requirements. And again, in computing, you have various different options available. You have machines which are compute optimized, machines which are memory optimized, machines which are storage optimized, and also we have certain machines such as preemptive, which basically means that you could get a machine to work on at a far lesser price than any other machine. But when we talk about preemptive, these are the machines which can be requested on demand and they can be taken back by Google at any time. You have networking related services, which can be very useful when you are setting up your applications or your services across globe. You also have different services which are specific to machine learning, and organizations which would be interested in working on machine learning or artificial intelligence would be really interested in using these services. There are also innovative solutions to work on big data and big data related technologies. Now, when we talk about Google Cloud Platform domains, so we can break down these services into specifics, such as you have compute. Now, the compute service allows for computing and hosting the cloud. Now, when you talk about computing, here there are different services such as App Engine, you have Compute Engine, you have Kubernetes, you have Cloud Functions, and Cloud Run. When you talk about storage and database, so the storage and database service allows application to store media files, backups, or other file-like objects. Now, various services under this are as follows. You have Cloud Storage, Cloud SQL, Cloud Bigtable for unstructured data. You have Cloud Spanner, Cloud Data Store, Persistent Disks, and Cloud Memory Store. When we talk about networking, the networking service allows us to load balance traffic across resources. Now, as I mentioned earlier, resources could be your different resources which you would be using from a cloud platform, such as your devices, your instances, memory optimized or CPU optimized instances, or other resources, creating DNS records, and much more. So various services under this are VPC, that stands for Virtual Private Cloud. You have Cloud Load Balancing, Cloud Armor, Cloud CDN. You have Cloud Interconnect, DNS, and Network Service Tiers. When we talk about the big data service, this allows us to process and query big data in cloud. Now, various services under these are as follows. You have BigQuery, Cloud, Cloud Data Proc, Cloud Composer, Cloud Data Lab, Cloud Data Prep, Cloud PubSub, which is publish and subscribing system. You have Cloud Data Studio. Now, you also have the developer tools, and developer tools service includes tools related to development of an application. Now, various services under these are as follows. That is, you have Cloud SDK, Software Development Kit, you have Deployment Manager, Cloud Source Repositories, and Cloud Test Lab. When we talk about identity and security, which is one of the primary concerns for any organization or any user who would be interested in using a cloud platform, Google Cloud really has taken care of this. So when you talk about identity and security domain, this deals with security services. Now, various services here are Cloud Identity. You have Identity and Access Management, that is Cloud IAM. You have Identity Aware Proxies. you have cloud data loss prevention API, security key enforcement, key management, service, and many more. You also have cloud services which are related to Internet of Things. So very much would be used by organizations who would be working on IoT devices or the data generated by these devices. So various services here are Cloud IoT Core, you have Edge TPU, and Cloud IoT. Also, when we talk about cloud AI, that is artificial intelligence, this comprises of services related to machine learning and much more. So you have Cloud Auto ML, Cloud TPU, Cloud Machine Learning Engine, Job Discovery, Dialogflow Enterprise, Natural Language Cloud, Text to Speech, and much more. If you would be interested in services related to API platform, then there are different services under this category or this domain. So you have Maps platform, you have APG API platform, monetization, developer portal, analytics, that is API analytics, APG Sense, cloud endpoints, and service infrastructure. So these are some of the listing of services under each cloud platform domain. Now let's look at Ferrero use case, and let's also understand what was done here. So Ferrero is one of the famous chocolate and ranks third among worldwide chocolate and confectionery producers. It was found in 1946 in Italy. I'm sure you would have seen the Ferrero chocolates when you would have gone out to buy some chocolates. So the challenges here was that Ferrero, as we know, is sold in every supermarket and is known for its quality. Once the business grew, some issues arose, right? And that's what happens when the business grows. You have issues popping up, which could be related to the volume of data, the speed with which the data is getting generated, the variety of data, and also looking at your platforms which support different dynamic applications or your scalability requirements, performance requirements, and so on. So it needed data storage, processing, and analysis system for a wide customer database. There was a huge gap between the company and the people who bought its goods because the company relied on data-given sales outlets. Now that's one of the challenge. Ferrero wanted to create a digital ecosystem where there was a point of contact with its customers and also a foundation for an innovative data-driven marketing strategy. What was the solution here? So one of the service of cloud platforms or Google Cloud Platform is BigQuery. And this was an answer to Ferrero's challenges since it was capable of hyper-fast and efficient data analysis as a solution. Now, as I mentioned, BigQuery is a data warehouse which allows you to store structured data. Now, this could directly be used as a service where you could store in any amount of data and you would not be paying for storage. So there are different pricing models, and for data up to 1 terabytes, you would not be charged anything. And if you would be accessing the data, that is reading the data or processing the data from BigQuery, that's where the pricing model kicks in. Now, using Google Cloud's BigQuery, business analysts of Ferrero were able to store and analyze massive data sets in a very reliable, fast, and affordable manner. Consumer behavior and sales pattern data reports were easy to build and automate. And the analysis also followed Ferrero to adopt advertising across various marketing channels to serve the customer needs in a better way. What was the result? They could divide their database into real-time, actionable consumer clusters to generate more accurate user profiles. Ferrero was also able to personalize its marketing strategies to match the user needs. Now, Google Cloud Platform completely tailored the website, mobile content, and advertising, and created a very cost-effective media buy strategy. Now, these were some basics on Google Cloud. Now, as I said, you can always find a lot of details about pricing, about services, and also all the services are accessible in your free trial account. Now let me just walk you through here. So one is you could always find details on documentation on each of these services. So if I would click on getting started, you have quick start, which basically shows you short tutorials. You have trainings and you have also certifications. Now if we click on quick start, now that takes me to this page, which shows me quick starts, or if you would want to understand about different projects, if you would want to look into the documentation of creating a Linux virtual machine or storing a file and sharing it, deploying a container, Docker container image, and so on. So you have a lot of quick starts here. You can also look at Cloud Minute. On the same page, on the right side, you have docs. And once you click on that, it takes you to these links. Now this shows you build solutions, which shows you top use cases, best practices, all the solutions. It's always good to learn from these use cases which are available. And here you have different featured products and all the different services which Google Cloud offers. Now you can click on featured products, and that basically shows you a list of these products. Now here we have all the solutions which you can look at: architecture, database, enterprise level, big data and analysis, gaming related, Internet of Things, and so on. Now if you go down here, it shows you featured products, and that shows you some of the important products such as Compute Engine, which is belonging to the compute domain. You have Cloud Run, you have Anthos, which is for migration and basically cloud adoption. When organizations would want to move from on-premise to cloud-based solutions, you have Vision AI, you have cloud storage. Now that basically allows you to store any kind of data, whether that's an object. So this is acting as an object storage. You have Cloud SQL, which is basically a ready-to-use service where you would be using MySQL, Postgres, or any other SQL Server database services. You have BigQuery, which is a data warehouse, which basically allows you to store your structured data. And then you have your AI and machine learning related products. So you have AutoML, Vision AI, Video AI, text to speech, speech to text, and so on. Now you also have different platform accelerators which can be used. And in any of these cases, for example, if I would click on Compute Engine, which is a featured product from Google Cloud, now that shows you basically your quick starts using your Linux machines, how-to guides, which tells you completely working on a VM instance or working on storage, working on persistent disks, and so on. And it shows you the documentation here. Now you also have products and pricing option, which you can see for GCP pricing. And you could straight away go to the pricing. You could be looking at solutions, which talks about infrastructure modernization. Now this is something which organizations are interested in when they would want to move from their on-premise solution to your Google Cloud. Now here I can say, for example, I click on infrastructure modernization. You can always find some case studies. What are the different solutions we have here, right? When you talk about Google Cloud. So you can always click on see solutions, and you can look at VM migration or SAP Cloud, right? Why Google Cloud, what it can be used for, VMware as a service, or HPC, that is high performance computing. And about these services, we will learn in detail later. Now I can go back on the same page where I was clicking on the services. So you have quick starts, you have how-to guides, you have deep understanding of different concepts, right? And here, if I click on all how-to guides, so that shows me what are the different ways in which you can work with Compute Engine and working with different instances. Although it's quite exhaustive content, but then if you follow steadily, then you can learn a lot about Google Cloud. Now here, I can just go back. So this is just giving you some idea on the different products which are available from Google Cloud, looking into different sections, finding right documentation here, right? And you can always look into each one of these in detail for each product which Google Cloud offers. Now, If we scroll down, we could see all the options or all the domains which we see here, right? Let me just go back because we got into solutions. Now we have quick starts, right? And then you can basically scroll all the way down to look at Cloud SDK, which can be set up on your Windows machine, like I have set it up on my Windows machine. Plus, when you use Google Console, you have a GUI, which I'll show you in a couple of minutes, and also a Cloud Shell where you can use your command line options to work with Google Cloud Platform. You have Cloud Console, which is nothing but your GUI to access your resources. Now, you can also look at in-depth tutorials, pricing, and you have different other options. So let's just click on pricing here. And then we have your price list, which basically gives you details of different services, what are available, and what are the services or what are the prices. So for example, if I click on Compute Engine, right, and this shows me the pricing aspect of Compute Engine, which belongs to Compute Domain. And here you can see you have VM instance pricing, you have networking pricing, sole tenant nodes, which are specific to particular organizations, or if organizations would want to have dedicated nodes, you have GPU based pricing, right? So general processing units, you have disk and image pricing, and you can click on any of the links and you can see pricing, which also shows you your different kind of machine types. So here you have different kind of machine types, which says N1, N2, N2D, E2. You have memory optimized machine types, you have compute optimized, you have premium images, and you can basically look at all the categories. You can look at disk pricing, which involves your persistent disk pricing for SSDs or HDDs. What are the kind of images, what are the different network services, right? And you can always look at your machine types. You can choose a particular region, right? There is the concept of region and availability zones here, and as per region you could look at the prices. You can also look at standard prices. You could be looking for what are the free tier machines. If I'm specifically looking for VM instance pricing, I can click on this one, and that takes me to the VM instance pricing. What is the billing module? What is the instance uptime? What is the resource-based pricing? And then you can also look at different kind of discounts, such as sustained use discounts, committed use discounts, discounts for preemptible VM instances, and so on. And this is how you can be looking at pricing for all different resources. And you can choose the resource which you are interested in, and then look for the pricing, benchmarks, reservations if you would want to use and you would want to benefit, if you would want to look at what are the quotas and limits, and so on. So please explore this link and you can find a lot of information when it comes to technical options, looking at different Google Cloud products, which we briefly discussed when it comes to domains and what each product can be used for. You can always come back to the main page where I was showing you different services. We went into pricing straight away, right? Now you can always come back to this page on your cloud.google.com, and then you have your solutions, which talks about different products, right? And you can click on these, or you can look into technical documentation. So this talks about your different featured solutions, infrastructure solutions, you have data center migration related, and so on. So I could be talking more and more about Google Cloud Platform. It's a ocean. It's a huge chunk of different services for different organizational requirements. So look into this link. And also what you can do is create a account on Gmail. I mean, you could create a free account, or you could go to cloud.google.com and then you could create a free account like I have created here, and I can just click on console. Now that's my GUI or Google Cloud Console, which basically allows me to work with Google Cloud. Now there are a lot of options here. By default, when you create an account, now in my case, on the top it says it's a free trial account. I have $300 credit, and out of that $251 is left, and 237 days out of a year are left for my account. Now here I can basically see the project, right? And by default we can create a project, or by default there is a project existing for any user. So when you log in, it creates a particular project, and you could create a new project, and project would be to dedicate your different services or different resources per different project. So this is your dashboard, which basically shows your project, which shows you a project number and a project ID, which is always unique. Now you can click on this, and this, if you would want, you can hide this information. You can also look into the documentation part of it. Then it shows you the different services or a graphical information of services which you might have used in past. So you have compute engine, which shows you how much percentage of CPU was used. You can always go to compute engine as a service. You can look at your Google Cloud platform status and look at the Google Cloud status. Now this is billing. Now since this shows me the billing period for April month, and I can always look at detailed charges. I can look at reporting. I can look at different APIs which Google offers. And for your different kind of work, you can always go to the API overview or the API link and enable or disable any API. Now, once you enable or disable any API, then you can use that. So you have news section, you have documentation, and you have getting started guides, which tells you how to work or enable different APIs. If you would want to deploy a pre-built solution, add dynamic logging, monitoring errors, deploying a Hello World app, and so on. Now this is your dashboard. I can click on activity, and that would show me what kind of activity I would have done in my cloud platform. I can always choose the kind of activities by saying activity type. I can choose the resources. Now it shows me that I created some VM instances, I deleted them, I updated some metadata, I basically worked on instances, I changed some firewall rules here. I have then also worked on some other services or APIs. So I created some buckets, which is for object storage. And again, I have been working with some instances and creating some firewall rules. Here, I have granted some permissions. I am setting up a policy, right? So this activity gives me a history of what things I have done over the past couple of months while working on Google Cloud Platform. Now, on the top left corner, you have the hamburger menu, which you can click on this. So that's your navigation menu. And when you click on this, this shows you home. It takes you to the marketplace. It specifically takes you to billing. You can always look at APIs and services. So here in API services, I can pretty much go to a dashboard and I can see a report on the traffic or errors or latency and the kind of APIs which are available. So you have Compute Engine API, you have BigQuery API, BigQuery Data Transfer API, BigQuery Storage, Cloud Data Proc. So these are some of the APIs or services I've used in past. Might be I was evaluating a product, might be I was using a particular product. So you have, whenever you would want to use a particular service from Google Cloud Platform, you would be enabling these APIs. So here we see some APIs for data proc. You have logging, monitoring, you have resource manager API, you have cloud SQL, which allows you to directly use MySQL or Postgres, you have cloud storage, right? And so many APIs. So if I would want to enable a particular API, which is not right now required, but then it's good to know, you can always click on this one. You can search for an API. So for example, if I would say data proc, right? And that shows me the cloud data proc API, which manages Hadoop based clusters and jobs on Google Cloud Platform. So I can spin up a Hadoop cluster and I can start running some jobs on a Hadoop cluster on demand. And as I'm done with it, I can just get rid of it. So this is an API which I would have to enable. And then for every particular service, you also have an admin API, which you would enable. Now, going back, so coming out from this API library, I got into API and services. Now there is, you can look into the library, you can look at credentials, and you can also look at different time intervals for which you can see the usage of your different APIs. Now, going back to the menu, you have support, wherein you can always reach out to the Google support team if you are using a paid version. Even with free trial, you can try to reach out and you will find someone to help, but it is always good when you have a billing cycle reaching out the customer care. You have identity access management and admin, and this is required when you're working with different APIs or services, when you would want to have relevant access. You have getting started, you have security related options, you have Anthos, which is mainly for migration. Now here you can look at your different domains, such as which we discussed. So you have compute, and in compute you have different services. So you have App Engine, you have Compute Engine, Kubernetes, you have Cloud Functions and Cloud Run. You can look into the storage aspect, which shows you Bigtable, which is usually and mainly for your unstructured data. Bigtable, which is something which gave rise to popular NoSQL databases like HBase and Cassandra. You have Data Store, which can be used. You have Firestore, File Store, Storage, which can be used to put in data of any kinds. You have SQL for structured data. You have Spanner as a service. You have Memory Store, and you have Data Transfer. Now, when it comes to the networking domain, you have all these services such as VPC, virtual private network, network related services for your load balancing, for using a cloud-based DNS or cloud-defined network. You have hybrid connectivity, network service tiers, security, and intelligence. Then you have other options for your operations which can be used. And here you have different other tools which can be used, such as Cloud Build. You have Cloud Tasks, Container Registry, Deployment Manager, and many more. Big data specific, you have the services here. So you have Dataproc, which can be used to spin up your clusters. You have publish subscribe messaging systems such as now Kafka, which you might have heard of, originates its idea from here. So PubSub, you have Dataflow, you have IoT Core, BigQuery, which is a data warehouse package or data warehousing solution from Google Cloud. Now, then you have your artificial intelligence related services and other Google solutions. So you can always find a huge list of services, or you can say at high level solutions offered by Google Cloud. And we can use these to basically test some of the solutions, use them, and work on them. So I'll give you a quick demo on different services which can be used here from your Google Cloud platform. Now this is your Google Cloud platform and this is your console. Now this also gives you a Cloud Shell which can be activated so that you can work from command line, and you can always find a lot of documentation on that. So you can also set up your Cloud Shell, that is SDK, on your Windows machine, and if you have set it up, then basically you could be doing something like gcloud, right? If the cloud has been set up. So in my case, I had set up the Cloud SDK, and basically I can get into that by looking at what path I have set up. So Cloud SDK, and then I can be using it from my Windows machine as per my comfort. I can also activate the Cloud Shell here, which will basically open up a terminal, and at any point of time you can open up this one Cloud Shell in a different window. It is preparing the Cloud Shell, where it will by default set up your project. It will set up the metadata, and now I am logged into my Google Cloud account from command line, and here I can basically use gcloud, right? And that basically shows you the different options which are available, which you can be using. So if you would want to use a particular service, you can also try giving a help, and that shows you how do you manage your Google Cloud platform, right? So you have different options for billing, to work with your different services, and basically you could be working on Google Cloud using this Cloud Shell from your command line. Usually for people who are learning Google Cloud in the beginning, it is always good to go for console and use your different services from here in an easier way. But as I said, you can always use the command line. For example, if I would just go ahead and type gcloud create instances, and that will directly take me to the Cloud Console documentation, which shows you different options which you can use to work with instances. So I could do a gcloud compute instances create, and then I can give my instance name and so on. And I'll show you some examples on that. So you can be using your Cloud Console, right, that is your Cloud Shell, and you can straight away start working from command line. However, I would suggest using console in the beginning, and when you are well experienced, then you can start using Cloud Shell to do things from command line. And when you are fully experienced, you can always switch, and certain things are usually useful or easier when done from command line, and some are easier when you do it from the console, and you can use any one of these options. Now we can go to Google Cloud Console. Now as of now, I can close this one. I still have my Cloud Shell open. If I would want to look into it, I can click on this one and I can straight away go to Compute Engine, where I would want to work on creating some instances on Google Cloud Platform using the Compute Engine service, and then basically connecting to those instances and basically trying out some basic things. So you can click on VM instances, and then once this comes up, I can always create some instances. Now if you see here, I have some instances already created, right? And I can continue working on those. I can create new instances. I can use different options while creating instances, and I'll show you that in a demo in quick seconds. So let's have a quick demo on setting up GCP instances. Now before that, let's have a quick recap. So when you talk about instance or a virtual machine, it is hosted on Google's infrastructure, right? And you can create your Google Cloud instance using this Google Cloud Console, that is by clicking on this and then going to Compute Engine and clicking on VM instances. Now you can also do that from Google Cloud command line tool, that is Cloud Shell, and you can be doing that using Compute Engine API. So Compute Engine instances can run the public images for Linux or Windows servers that Google provides. You also have option of creating or using custom images that you can create and import from your existing systems. You can deploy Docker containers which are automatically launched on instance running containers, optimized OS. Now, when you talk about instances and projects, always remember that each instance belongs to a Google Cloud Console project, and a project can have one or more instances. When you talk about instances and storage options, each instance has a small boot persistent disk, which I will show you in further screens, that contains the OS. You can add more storage space if needed. And when you talk about instances and network, a project can have up to 5 VPC networks. So VPC network is virtual private networks, wherein you can virtual private cloud networks, where you can have your resources within your own subnet. And each instance belongs to one VPC network. Now, instances in same network can communicate with each other through local area network protocol. An instance uses internet to communicate within any machine. So that could be virtual, physical, or outside its own network. When you talk about instances and containers, you should remember that Compute Engine instances support a declarative method for launching your application using containers. Now you can create a VM instance or a VM instance template. You can provide a Docker image and launch the configuration. So there are different ways in which you can create these instances. And once you create these instances, you can say, for example, you're creating a Linux instance. You can associate SSH keys with your Google account or your G Suite account, and then manage your admin, non-admin access to the instance using IAM roles. If you connect to your instance using G Cloud or SSH from console, which we will see later, Compute Engine can generate SSH keys for you and apply that to your Google Cloud or G Suite account. Now, what we can do is we can see how we can create your Google Cloud instances from your console or from the command line. Let's have a look in creating instances using GCP console. Now that we have learned on some basics of Google Cloud Platform, what are the different services, what are different domains, basically looking at your Google Cloud Console or even Cloud Shell, let's go ahead and create some VM instances. Now that's from your Compute Engine service, and let's try connecting to these instances and see how this works. let's also see what are the different options which are available when you would want to create the virtual machine instances here. So when you click on your drop down from the top left and choose compute engine, so it brings you to this page. So I can show that again. So you can click on compute engine, click on VM instances, and that basically brings you to this page. Now here it tells you compute engine lets you use virtual machines that run on Google's infrastructure. So we can create micro VMs or large instances running different distributions of Linux or Windows using standard images, that is public images, and you can also have your own image. So let's create a VM instance by clicking on create. Now that's basically helping me to create an instance here. So it shows me the instance name. I can give it something. So let me say C1. Now I can add labels. So what is label? It basically allows you to organize your project, add arbitrary labels as key value pairs to your resources. So this is basically categorizing your labels in projects if you have multiple projects. Now remember, if you have your Cloud Console and if you have created your free trial account, it will allow you to do these things. If not, you may have to go back to the billing section and see if the billing is enabled. Which also means that when you're creating your Google Cloud account, it will ask you to key in your credit card details, but they do not charge anything, or they might be $1 or 1 rupee depending on your location, and that's also refunded, but that's just to verify your card. Now, once I've given the name, I can choose a region. So I would basically choose Europe. Since I'm in Europe, I would be clicking on Europe West 3, and here I can choose an availability zone. Availability zone is basically to make your services or instances or any other resources highly available. So you can choose one of the availability zones. Now I would choose say West 3. Now this one, we can scroll down and here it says machine configurations. You have general purpose machines, you have memory optimized machines, which is M1 series, and you can always go back to the Google Cloud page and see what a particular kind of machine specializes in. So I would click on general purpose, and in general purpose you have different categories. So you have N1, which is powered by Intel Skylake CPU platform, or you have E2, which is CPU platform selection based on availability. So let's have N1 selected. Now this one shows me the machine type, and if you are using your free tier account, then you can start with correcting a micro machine, which is 1 virtual CPU core. You can go for a G1 small, which is 1 virtual CPU core and 1.7 GB RAM. You can even go up to a high-end machine, and then you can basically see if you're using a free account how many of these machines you can use. If I would be selecting 8 virtual CPU cores and 32 gigabyte of memory, then it would allow me to create at least 2 instances by this configuration. We will use N1 standard, which is 1 virtual CPU core, 3.75 GB memory. Now, then we can also deploy a container image to this VM instance. If you would be interested in deploying a container image, let's not get into that right now. Here it shows you the boot disk and it shows you Debian GNU 9 Linux 9. What I would do is I can go for this distribution, or I can choose a Linux distribution of my choice. So here you have public images, you have custom images, you also have snapshots if you have created backup of your previous images. Here I can choose, for example, Ubuntu, and then I can choose a particular version. So let's go for Ubuntu 18.04. You can go for the latest one also. 18.04 would be good enough. And here it tells me what is the boot disk. So you have SSDs, or you have standard persistent disks. Now SSDs are little expensive in comparison to your standard persistent disks or your SSDs, but then SSDs are faster. So as of now, we can choose standard persistent disk as it is, and we can let the gigabyte be 10. Now, depending on your requirement, you can increase this. You can even add disks later. That's not a problem. Click on select. Now here I have access scopes. So here I will say allow default access. You can also set access for each API, or you can give full access to all cloud APIs. So that based on your requirement, you can anytime change later also. We will also say allow HTTP traffic, and we can also choose allow HTTPS traffic. That basically allows me to access this machine or services which are HTTP based accessible from this machine. Now I can just click on create. However, it would be good to basically enable connectivity to this machine. Now we can do that in different ways. One is when you bring up your machine, it will have an SSH access which you can log in from the cloud platform here itself. Or what you can do is you can create a private and a public key using some softwares like Putty or PuttyGen. So for example, if you do not have that on your machine, you can just type in download Putty. That takes you to the putty.org page, and here you can click on download Putty and scroll down, which shows you for your 64-bit machine, which I have in my case. You can download putty.exe, which is basically your SSH and Telnet client to connect to your machines. You can also use PuttyGen, which will be allowing you to create a private and a public key, which I have done in my case. Let me show you how. So what you can do is you can go to PuttyGen to begin with, and here you can click on generate. Now then, to have this key generated, just move your cursor on the top here in the empty space, and that creates your key. You can give it a name. So for example, let's give a username. I would give HDU. Now I can give a password for this one. So let me give a simple password. And what I can also do is I can copy this public key from here, and for my later usage, I can just keep it in my notepad file, which I can use later, and I'll show you when. So now we can save this private key, and this will basically allow me to save my private key. I can choose desktop and I can give it a name. So let's say new key, and that will be getting saved in a .ppk file. So let's save it, and that's done. So we also have our public key and we have saved our private key. Now we know that when you would want to connect using SSH, you need your private keys to the client, and public key also has to be existing. So let's take this public key. So let's do a Control A. I'm going to copy this, and I'm going to come back to my Google Cloud Console, and here you can click on security. So you can click on the security tab here, scroll down, and just give your public key. Once you give that, it resolves and shows you the name, and this is good enough so that I can use my SSH client to connect to this machine. I can click on create, and this will basically create my VM instance. It will take some time, and then your instance will have an internal IP which will show up here, external IP, and it will also show you options to connect to these machines. So this is my internal IP, this is my external IP, which I can use to connect from a client. I can easily connect from the option here which says SSH, and I can say open in a browser window. I can even open this in a custom port. I can look at the gcloud command, which you can give from Cloud Shell, or you can use another SSH. So let's first do a open in browser window, and let's see if this connects. So we can easily connect to our instance, the Ubuntu 18 instance, which I just set up here easily in a couple of seconds. Now this is trying to establish a connection using your SSH keys. And when you do that, it also basically brings up this web browser. So I'm already connected. It shows my username, which is my cloud account username, and I have been connected to this machine here using SSH. It did not ask me for any password, and basically now I can just check what do I have in my Linux file system, right? And I can anytime log in as root by doing a sudo su. For example, let's try installing a package, and I can say apt-get install vim, or apt-get install wget, or apt-get install open SSH, and all these packages are already existing, so not an issue. Now I can start using this instance. I can just look at the disk, what is available. Okay, now we gave around 10 gigabyte, out of which we see 8.3 gigabyte here for the dev SDA1, and then 1.8 gigabyte available, and you can continue using this machine. This was the easiest way of connecting to a VM instance using SSH. Now what we can also do is I can just leave this and I will now try to connect using an external SSH client, right? And here you can copy the public IP. So when you want to connect to an instance, you will have to get the public IP. Also remember that if you select and stop this machine, which will stop your billing counter, and if you start it again, the internal IP will remain same, but the external IP is the one which will change. I can obviously select this machine anytime, and I can do a cleanup and I can delete it. I can do a start of the machine if it is stopped, and I can even import the virtual machine to be used later. So there are different options which you can always use. So this is my instance, and if you would want to look at the details, click on this one, C1, and that should basically allow you to look at the details. So it shows you what is the instance ID, what is the machine type, is it reservation specific, what is the CPU platform, what's the zone, and all the other details. At any point of time, if you would want to edit, you can always click on edit and you can change the details as you need. Now you can also look at the equivalent REST command to basically use the REST API to connect to this instance. For now, I have copied the public IP and I would want to connect it using PuTTY. So let's go in here and let's give it the host name. So I can give Ubuntu, I can give my IP address. So that's in my session. Now I will click on SSH. I would go into authentication. I'll click on browse. And this is where I need to choose the PPK file. So this is the one which we created, new key. Let's select this. And then I can come back to session. I can even save this and I can call it as my instance one. Let's save it. And you can create any number of instances. So you see, I have created different instances here for my Google Cloud or Amazon related instances. And I can click on open. It says the server's host key is not cached in the registry. That's fine. Just click on yes. And basically it says no authentication method supported. Now this could be because we have not enabled your SSH access. So let's look at that. So now let's see if we were trying to connect using PuTTY. What was the issue here? So if I go back to my PuTTY, select my instance, load it. It says port 22. I'm giving the username, which is Ubuntu. Or sorry, that's the wrong username we gave, and that might be the reason. We had set up the user as SDU. So let's save this again. And now let's try connecting to this one. And it asks for my password, and you are able to connect this. Right now, if there was any other issue related to network connectivity, then we could look at the rules, the inbound and outbound rules, which allow us to look into the machine. Now we are connected to our machine here using HDU user. I can log in as root and I can continue working. So not only from the SSH within the Cloud Console, but you can use an external SSH client and connect to your machine. So this is your Ubuntu machine, and we can basically look at the space, and that basically confirms we are connecting to the same machine, which shows 8.3 gigabytes here and 1.8 gigabytes here, which we were seeing from the SSH in the browser. Now let's close this and let's go back to our instance page. Now here you can always look at the network details, and this will show you your different kind of rules, that is ingress or egress rules, which basically allows to connect to this machine from an external network or for this machine to connect to an external network. So here we have different firewall rules, which shows default allow HTTP, that's your ingress rule. And it tells you apply to all. It shows me what are the IP ranges where I can specifically give the IP of my machine. It shows the protocols. It shows what are the different ports which you have used for these services. For example, RDP or SSH, which shows 22. You have ICMP, HTTP and HTTPS. Now, anytime if you would want to make a change to these rules, that can be done by going into your network details. And say, for example, you would want to work on firewall rules. So we have these firewall rules here. You can click on this one. So right now we are looking into the network domain and we are looking into VPC network. right? And this shows me what are the different rules we have. Now, if I would want to create a different firewall rule for a different protocol, I can always click on create firewall rule. I can give it a name. Okay, I can say what if you would want to turn on the firewall logs. You can basically say what is the kind of traffic. So ingress applies to incoming traffic and egress applies to outgoing traffic. And you can then basically choose what are the IP ranges from where you want that connection to be coming in or to going out. You can choose a particular protocol. You can give a protocol here with comma separated values, and you can create a firewall rule. So this might be required depending on the services which you are running, wherein you might want to enable your access to your machine from an external service or to an external service. So you can always go to network details. From here you can then go into firewall rules, create a firewall rule, apply that to your instance and restart your instance. So as of now, we don't need to create any network details here because my ingress or egress rules are already available. Right now, I can basically then have my instance stopped and removed. So I can just do a stop, or since this is running, the ideal way would be to do a stop. I could also do a reset. Now, what does reset do? Reset does not basically delete the machine. What it does is it does a cleanup of the machine and it brings it to the initial state. So sometimes we might have installed certain things on our machine. We would want to clean them up, and at that time reset can be useful. I can basically click on delete, right? And I can select this and I can do a cleanup. And this is good always when you're using a free trial account. Try to use different services, play around with them, and then you can clean up so that you do not waste your free billing credit, right? And you can use it for meaningful stuff. Now I have clicked on delete, and within a few seconds my instance which I had created will be deleted. Also to remember is if you are creating multiple instances, then you can connect from one machine to other machine using SSH by using the private file. So for that we can learn in detail later. So this is just a simple example of using your compute engine, creating your instances, connecting to it from an internal SSH or from an external SSH client such as PuTTY, where you have already created your private and public keys. Now I can click on the browser here, and then I can basically come out and I can basically be looking into any particular service. So we just looked into compute engine, right? You have different other options. You have instance groups, you have instance templates. For example, let's click on instance templates here, and that basically shows you that you don't have any instance template. And this basically facilitates, say for example, you are working as an admin and you would want to create an instance template so that using that you can describe a VM instance, and then you can basically use this template to create different instances. You can go for sole tenant nodes, you can look for machine images, you can also look at your disks, you can create a snapshots, and you can look at different options here. Now let's come back here and let's click on home, and that should take you back to your home page, which basically shows you if a particular API which you have used recently, which shows me in the graph here. So I can go to the API's overview, right? And that basically shows me if there were any errors, if I was using the compute engine API to basically create a VM instance, and that's why we were seeing some spike in the graph. So this is a quick demo of using your compute engine service provided by Google Cloud, wherein you can create VM instances and use those VM instances for your application installation, for any other purpose. Now that we have seen how you use your Cloud Console to create an instance and also clean it up, let's also understand how you can do using your command line options, and let's see what it takes or what are the different commands which you can use to create your instances. Now you can always, when you're creating an instance, you can use compute engine which provisions resources to start the instance. So instance basically has different states which we can see when we are creating the instance. So you basically start the instance, instance moves into staging, that is prepared for your first boot. Finally, it boots up and then it moves into running. So when you look at instance states, which we will create instance and see, it will basically have different states such as provisioning, where resources are being allocated for instance, but instance is not yet running. Then it goes into staging, where resources have been acquired and instance is being prepared for your first boot. Then instance is booting up and running, and if you are stopping an instance, it goes into being stop status and it would be moved to the terminated option. You can also do a repairing of instance, and finally you can terminate your instance or clean it up by stopping and then deleting it. Now, when you say stopping and resetting an instance, you can stop the instance as I showed earlier if you no longer need it. But if you need for future use, you can just use the reset option, which will basically wipe the contents of instance or any application state. And then finally, you can stop it and have it terminated. Now, when you would want to do that using your Cloud Console, we have seen the options. Now, let's also see from the command line tool how you can do it. So here I have the Cloud Shell, which I brought up from here, and I basically opened it in a new window. So command line tool enables you to easily manage your compute engine resources in a friendlier format than using your compute engine API. Now, gcloud, which is part of Cloud SDK, is the main command here, and then you can always autocomplete the different options here. So when you would want to create or work on gcloud, you can just type in gcloud here, and then for example I could just say help to see different options of gcloud, which will show me different options which you can use here. Now we would be interested in compute instances, so I could also do a gcloud compute instances, and then I can basically say create, and then I can do a help. Now that should show me different options which work with gcloud compute instances create command, which is expecting an instance name. So your Google Cloud SDK, which we can set up on our Windows machine or even on your Linux machine, is a set of tools that helps you to manage resources and applications hosted on your GCP, that is your Google Cloud Platform. Now here you have options such as gcloud, which I'm showing you right now. You have gsutil, and then you have bq, so that also can be used. So you can set up a Google Cloud Compute if using gcloud. Now what we can do is, if we are setting up our SDK on our Windows machine, then we would have to do a gcloud init, which basically initializes your configurations for gcloud. Now here we are using a Cloud Shell which was started from the console, and we don't have to basically give your gcloud init command because it's already initialized. Now you can always look at your default zone, you can look at your region, what is being used. All those things are coming from the metadata which is being used. So for example, I could be looking at the metadata for my particular project by just doing a gcloud, and then I can say compute, and I would be interested in project info. So I can just do a project minus info, and then I can do a describe, and then I need my project ID, so I can say minus minus project, and I can get my project ID from here. So you can click on this one, and that's my project ID. So I can click on this one, and here I can just do a right click, and if it does not paste, then you can do a Control V, and then I can try to look at my project info. So this basically will give me the metadata which is by default set, and we can always look at what are the regions or what is the zone which has been set. So if it has been set, so I'm looking at my details, it is showing me my SSH keys, and then it can be using your default region and your default available zones. It also shows my username and other details. So this is basically to look at the metadata which is available. Now at any point of time, I can basically say add metadata. I can basically choose metadata option, and I can say my default region should be Europe, which I was choosing earlier. So I can just bring up this command again. And what I can do is I can say here where I have gcloud compute project info, where I did a describe earlier. Now what I can also do is I can just say add metadata, and then I can specify what is the metadata I would be interested in adding. I can then say Google compute default region, and then I can basically give a region, for example Europe, and then I can say West 3. And if you are not well experienced, you can always do it from console, or you can be doing it from here. So I'm giving Google Compute default region. Then I can also give a Google Compute default zone, and then I can pass in a value for default zone. So I can say Europe West 3, and then basically I can give an availability zone. So if it is basically giving me some error where I'm trying to pass in these values, so I can just give it this way, and then it basically says that if you can look into particular help to see what is the command which you would have to do. Now I can basically do a gcloud init here, initial configuration, and this basically says that it is initializing my default configuration. It says reinitialize this configuration from Cloud Shell. You want to create a new configuration. So if I had updated my metadata, then basically I could just do a cloud init, and I could be reinitializing my default configuration or properties which I have passed in. So as of now, I will not activate or change the default region. Let's go for a simple way in which you can create your compute engine. So for example, I'll just say 1, and it is reinitializing. It asks me what is the username, and let's select that. It says what is the project, and let's select that. And do you want to configure a default compute region and zone, right? And I will just say yes. And basically then it shows me different options which we have here. So there are too many options here. And then here we were interested in Europe West 3. So let's choose 21, right? And then that basically allows me to choose my region and my zone. So it also gives you some specifications. So it says your project default compute zone has been set to Europe West 3A. You can change it by running gcloud config set, and you can give a compute zone, right? So I can always give these commands. I can get help information here. So I can just say gcloud config set, and I can be specifying the compute zone. So I can say compute/zone, and I can give a zone. I can say compute/region, and I can give a region name if I would want to do it. Or the easier way is like what I did right now. So you can basically do a command gcloud init, and then basically it allows you to change your configuration or set default things here. You can all the times you can say gcloud config unset to basically remove a compute zone or a compute region. Now there are different ways. So if you were working on a Linux machine, you could always use an export command, something like this. So you could do a export cloud SDK, and then you can say compute_zone, and then give your zone name, or compute_region and give your region, or you could add it in your bash rc file, right? Now that is when you have your cloud SDK set up on your Linux machine or on Windows machine, and you would want to specifically set a zone and a region for all your compute related resources. So we don't need to do that. The default settings are already given here, right? And what we can do is we can start by quickly looking into gcloud compute instances options. So I can say gcloud compute instances, and then I can just do a list. At any point of time, if you would need help, you can just do a gcloud compute and then say minus minus help, or I could just do a gcloud compute, and that shows me different options which I have here from which I use instances. I can always type instances and again hit enter, and it shows me different options what you would want to do. So I can initially just type list, which should show me what are the lists or what are the instances available. And as of now, we don't have any instances. I can always do a list and then I can specify minus minus format and then try to get the information in a JSON format or YAML or minus minus format text. So you can always do a list, you can do a filter. So there are different options with your list, and you can try doing a help here, and that basically shows you what are the options. So for example, if I do a help and it shows me with list what are the things you can do. So you can give a name, you can give a regular expression, you can say in particular zone, you can use a minus filter. So there are different commands which are available, and you can always find all those options here as I showed you earlier. So now what we would be interested in is basically going for your compute instances. I can always do a SSH and I can create an instance. I can add and remove metadata, right, for my instances by giving a particular zone, by giving a particular region, and if you would want to do that. Now here what we can do is we can basically create an instance by just giving a name to that particular instance, and we can then go back to our console and see what has it done. So I can say here create, so that's an option. Let's see what does the create do. So it says, okay, you are giving a create option, but you would have to give a name. So let's say, let's call it E1, and that will be the name of my instance. And this one is an easy command from your Cloud Shell, which basically creates an instance. You see the zone which has been set. It is the standard machine type. It is not preemptible. It has an internal IP and it has an external IP. Now I have created an instance, and here I can just go back and then I can just do a refresh on this page, and that already shows me the instance which I've created. And then you can use the same method to connect to it using an SSH. So I have an instance created from my Cloud Shell, and what I can do is I can basically look into instances and see what are the different options with instance. So if we did a create, right, you have an option delete. We did a create, you have an option delete. You can be then deleting the instance from the command line, or you can use other options. So you can do a list, you can do a stop, you can start. So I can basically do a stop, and let's say even let's go ahead and do a stop. Commands are pretty easy here to remember, or you can always use the help option. And now I'm trying to stop the instance, and then basically I can go ahead and delete it. So this is a simple way where I created a instance from the command line or from the console which I showed earlier. And similarly, you can be working with other options. So now I've created stop the instance. Let's do a listing to see if my instance shows up. It shows up, right? And it says the status is terminated. So you have stopped it. It's in the terminated status. And now what I can do is I can go ahead and delete it. So it says this will be lost. Are you sure you would want to continue? Just say yes, and that should take care of deleting your instance. So this is a quick demo on creating your instance. We have already seen how you can connect to these instances using SSH. Now that we have created instances, let's also see how to use Google Cloud's storage service, which can be used to load data or upload data. So for this, we will have to look into your Google Cloud storage options. And here you can look in cloud storage. So let's go back here on the top, which shows me different services which we have here. And let's look into storage. So this one shows me your storage option. Now you can click on browser and that basically shows me your storage browser, which shows me on the top you have options for creating a bucket. Now Google Cloud Storage allows you to store any kind of data here. The easiest and the simplest way would be by using Cloud Console, although you can again use Cloud Shell, and in that you can use your gsutil command. And gsutil basically has different options where you can be using, say for example, I would want to work on buckets, so I can be using MB, and then I can use my command line option to create buckets. I can put in data there, I can browse it, and I can access the data from command line. So let's create a bucket here. Let's click on this, let's give it a name. So let's say my data important, that's the name. Now I can click on continue straight away. I can look into all of these options if I'm interested in. So you can basically be looking at your monthly cost estimate in the beginning. Now I can click on continue, or you can say choose where to store your data. And this one shows you different options. So you have region specific. So let's also give the bucket name with all lowercase. That's what is required. Yeah. So coming back to the location type, you can choose multi-region, which basically allows high availability. So your bucket or your storage option will be accessible across regions. You can also give dual region and high availability and low latency across two regions. I can also say region specific. So for our use case, we can just give region specific, which can keep our cost low. But in business use cases, you would be going for multi-region. Now here you have location, and I would again go for, say, Europe. And let's choose Europe West 3 Frankfurt. It is always a good practice that when you create your instances, when you create your storage, or you use different services, try to have a geographical region chosen, and then you would try to put things or your services within the particular region, within a particular zone, unless you would want to make it accessible and available across regions. Now I can then choose a default storage class. So when you say default storage class, there are different storage class, and each one is for a different use case. So you have standard, which is best for short-term storage and frequently accessed data. You have nearline. So this is basically best for backups and data access less than once a month. You can also have cold line. So these are basically like your cold storage or freezing storage, which you might have heard generically as terms. So you can choose one of these storage classes depending on what will be the use case for this particular storage bucket. So let it be standard. Now how to control access to objects. So you can basically say specify access to individual objects by using object level permissions. Now you can give permissions to the bucket. You can just say uniform access to all objects in the bucket by using only bucket level permissions. So you can choose that. You can also go into advanced settings, and here you can see different ways in which you can have configuration set up. Now you can also have a retention policy to specify the minimum duration where that this bucket's object must be protected from deletion, and you can set a retention policy. We'll not get into all that. We will just first try creating a bucket. So just click on create, and that should create your bucket wherein I have my bucket. Now I can click on overview to see the details. What is the region, which region it belongs, what is the storage class. Anytime you can always click on edit bucket and make some changes here. You can look at the permissions. So bucket uses fine-grained access, allowing you to specify access to individual objects. And then you can basically look at who has access to this. So in my case, editors of the project, they basically are the bucket owners, owners of project, viewers of the project, right? And you can basically choose what kind of access you need. So for this, you can always go into cloud storage, and then you can decide what kind of access you would want to give, whether that's a storage admin, it's an object admin, object creator, object viewer, and so on. You can always look at storage legacy, and for any other services, depending on what APIs you have enabled, right? you can always control your permissions. So right now it is storage legacy bucket reader, and that's fine. And this one is bucket owner. And then might be I was using some other services like Dataproc, which uses cloud storage, and that's why I've given Dataproc service agent also. So these are some of the members you can remove. You can view by specific members, you can view by roles. So what are the different roles which have access to this? So it says storage legacy bucket owner. There are 2 owners based on this particular project. So these are auto controlled, but then you can add or remove machines. You can save storage cost by adding a lifecycle rule to delete objects after the duration of current retention policy. So you can add different policies and you can basically control your bucket. Now my bucket is already created, right? So I can go back and then I see my bucket is already here. I can click on this option and you can anytime edit the bucket permissions. You can edit the labels, the default storage class. You can just go ahead and delete the bucket. You can export it to cloud pub sub. So basically, if you would want to have the content from this bucket being accessible in a message queuing system, you can go for pub sub. You can process with cloud functions and you can scan with cloud data loss prevention. So there are different options which are available. We can always select this bucket and delete it. Now I can click on the bucket and that basically shows me different ways in which I can upload some data here. So I can just click on upload files. And here, then I can choose some files. So for example, I'll go in here, I'll go into data sets, and I have different data sets. So for example, let's choose this one, which is a CSV file. And then I'm just uploading this to my cloud storage, right? It's as simple as this. So you can drag and drop your files, or you can just upload your files, and my file is uploaded here. Now I can basically edit permissions for this one, right? So this is in the bucket. So anyone who has access to this bucket can basically download this file. They can copy, move, or rename this. You can export it and you can look at the permissions of this file. So let's look at edit permissions, and it says for this project, whoever is the owner, it has access. I've also given a specific user, my Gmail ID, and I've given access. So at any point of time, you can just say add item, and then you can start giving different kind of accesses. So let's click on cancel here. Now my data is already uploaded into this particular bucket, and that's a simple usage of your cloud storage. Now what we can also do is I can basically select this and I can delete it. I can also create specific folders and then basically load data into it. I can click on this one. I can just do a download, and then I can download it anywhere on my machine. So let's go to desktop and let's download this file. So we not only uploaded some content in the bucket, but we also downloaded that in a different location, which will be accessible. Now, what I could have also done is I could have created a folder here, and I could have specified, say, for example, immediate data. Okay. And I'm clicking on this one. So that's my immediate data. I can click on this one, and now I can upload my data specifically to this particular folder. By using the same mechanism, you can just do upload file. Let's choose air passengers. Let's do a open, and my file will be uploaded. So you can always choose what is the retention expiry date for this one. So as of now, there is nothing, right? But you can be deleted. Objects can be deleted or modified until they reach their minimum duration. You can control all of that. You can basically download it, right? You can copy it and you can move it and rename it. So this is a simple example where I created a particular bucket, right? Now, if for example, you click on this transfer, so it says cloud storage data transfer products have moved. You can now find storage transfer service, on-premise data and transfer appliance in new data transfer section, right? So you can always go back to cloud storage. You can also look at transfer options, which are mainly when you are using an on-premise service and you would want to upload data in a Google Cloud. right? So this is my bucket here. Now I can go to Cloud Console, and here what I can do is, if I would be interested in working, so I can just say gsutil, right? And then we have, for example, let's try a help, okay? And that basically shows me my gsutil. Now you can always go to quick start gsutil tool, and this is one more way wherein basically you can do it from the command line. So working with buckets, so you can do a gsutil mb -b and then on a particular zone if you would be interested in, and then you can say gs colon and give a name. So my awesome bucket, this is how you will create a bucket, which will show you it is creating a bucket. And then basically you can upload an image or some data from internet. You can just do a wget, download the file, and then you can just do a gsutil copy command, and that basically will pick up the file from your Cloud Shell location, put it in your bucket. Once you have done that, you can always do a copy, right? So here you are doing a copy from your local machine, that is your Cloud Shell machine, to your bucket, and you can do the reverse of that. That is, you can do a copy and you can point your bucket and the file and download it to your desktops. So you can just download that using the command line, and you can copy the object to a folder in the bucket. So that is by creating a particular folder, and you're pushing the file into a particular bucket. You can list the contents of a bucket using ls and then give your bucket name. So gs colon. So we can just try this one to be simple, and rest you guys can try. So here you can just do a gsutil, you can do a ls gs colon / and then I need to give my bucket name. So in my case, the bucket name was my data important. So let's try that. So let's say my data important, and I'm trying to list the bucket and the content it has, right? And then you have a folder, and then you can look into the folder and look into the files. So this is a simple, quick option wherein you can use your Cloud Shell. You could be using your Google Cloud SDK from your local machine, or you can be using Cloud Console to create a bucket, upload some data on it, download the data, see if the data is accessible, and that basically shows you the power of cloud storage, where you can easily upload any kind of data. Now, what we can also do is, as you're using a free account or even a paid account, unless and until you would want to keep the bucket, you can select it and you can just go ahead and delete it. So this will basically ask you to key in the bucket name, and let's say my data important. You need to confirm your bucket name, click on confirm, and you could have done that using gsutil and a delete command from the command line, that is from Cloud Shell. So we have now created a bucket. We have uploaded some data into it. We saw how you can download it or create a folder and upload some specific data into it. And also you can do the same thing using gsutil tools, wherein you can list your bucket, create your buckets, delete it, create some folders into it, and do everything from the command line. So this is, in simple way, you can use your GCP, where either you can spin up your machines or you can use cloud storage to basically use a storage or a easy to use instance on Google Cloud Platform.
So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
The cloud is much more than just a reliable storage solution. The year 2021, like the year before, proved to be a watershed event for cloud computing. It gave businesses more freedom to operate in the face of COVID-19. Cloud computing, according to IT experts, will be at the forefront of all technologies used to address key businesses concerns in the coming years. Cloud computing has generated more anticipation, excitement, and investment than any other IT area in the last decade. According to IDC, the cloud will increase at a rate of 22% next year, with a market value of $277 billion. As a result, there will surely be a significant demand for cloud professionals. Therefore, a right certification in cloud computing can help you earn a handsome salary of $145,000 to $227,000 in the United States and close to 16 lakh to 24 lakh rupees in India. So let's have a look at the top 10 certification in cloud computing. The first one is AWS Certified Solutions Architect Associate. AWS Certified Solutions Architect Associate is a set of technical certifications offered by Amazon Web Services for beginners and professionals working in enterprise architecture and solutions architecture. This certificate aids in the identification and development of personnel with crucial capabilities for cloud implementation. AWS Certified Solution Architect Associate certification verifies your competence to build and deploy distributed systems on AWS. So this certification is for persons who can do solution architecture, such as deploying and securing web applications, and who have worked with AWS services for at least a year. And its difficulty level is easy. Skills required for this certification is understanding of specific programming or scripting languages like Java, Python, C#, and many other programming languages available. Data storage fundamentals, networking, AWS service selection, cloud-specific patterns, and technologies. Moving on, here are a few certification details you will need to proceed with its examination. Cost of examination is $150 USD, and the average annual salary is $130,883. The duration of this examination is 130 minutes, with number of questions 65. You have multiple choice and multiple response questions, and the passing score is 70%. And the renewal time of the certification is 2 years. The companies hiring are Amazon, IBM, Capgemini, Mindtree, and IQVIA. These are the top companies that hire. Second is AWS Certified Cloud Practitioner. The AWS Certified Cloud Practitioner certification is a foundational level test designed for people who can successfully show an overall understanding of the AWS cloud according to Amazon. This exam verifies a candidate's understanding of essential cloud infrastructure and architectural concepts, as well as key AWS services. The certification provides an overview of AWS key services, as well as security and network. So this is the ideal cloud certification for beginners or anyone interested in learning more about cloud computing and the AWS cloud platform. So the difficulty level is easy. The skills required for this certification is oversight on creating architecture for AWS platform, ability to deploy AWS solutions and applications, building cloud solutions, developing plans for the adoption of cloud solutions, management and monitoring of cloud platforms. Moving on, here are a few certification details you will need to proceed with this examination. The cost of examination is $100 USD. Average annual salary is $113,932. Examination duration is 90 minutes. Number of questions is 65. Types of questions are multiple choice and multiple response question. Passing score 70%. And again, the renewal time for the certification is 2 years. And the famous company hiring are Amazon, NetApp, Accenture, Deloitte, and Soliel LLC. Moving on, third is AWS Certified Developer Associate. AWS Certified Developer Associate is an Amazon Web Service examination that measures a person's ability to successfully demonstrate, deploying, and maintaining applications on the AWS platform. This is the ideal cloud certification for programmers and software developers interested in building cloud-native applications, and the difficulty level is intermediate. Skills required for this certifications are: use the AWS Services, APIs, CLI, and software development kits to write applications, identify key features of AWS services, understand the AWS shared responsibility model, use a continuous integration of continuous delivery pipeline to deploy application on AWS, and use and interact with AWS services. So here are the few certification details. Cost of examination is $150. Average annual salary is $130,272. Exam duration is 130 minutes. Number of questions is 65. Type of questions, multiple choice and multiple response questions. The passing score is 70%. Renewal time is 2 years. And the companies hiring are Amazon, IBM, Capgemini, TCS, and Oracle. Fourth is AWS Certified System Operation Administrator Associate. The AWS Certified SysOps Administrator Associate certification is designed to demonstrate technical skills for system administrators in cloud operations jobs. This certificate assists organizations in identifying and developing personnel with crucial abilities for cloud implementation. The ability to develop, manage, and operate workloads on AWS is demonstrated by earning this certification. This associate certification is for professionals who have at least 1 year of experience with AWS deployment, management, and operations. It teaches you how to identify the right service for your needs, and the difficulty level is intermediate. So these are the skills required for the certification: understanding of AWS tenets, hands-on experience with the AWS CLI and SDKs tools, understanding of network technologies, understanding of security concepts with hands-on experience in implementing security controls and compliance requirements, understanding of virtualization technology. Moving on, here are a few important details related to this certification. So cost of examination is $150. Average annual salary is $111,966. The duration of examination is 130 minutes and the number of questions is 65, which are multiple choice and multiple response questions with passing score of 70% and renewal time of 2 years. And here are the companies hiring: Amazon, IBM, Capgemini, TCS, and Oracle. Fifth is Microsoft Certified Azure Fundamentals. Azure Fundamental Certifications allows you to demonstrate your understanding of cloud concepts, Azure Services, Azure Workloads, Azure Security and Privacy, and Azure Pricing and Support. The Azure Foundation certification intended for people who already have a basic understanding of cloud services. It will explain you cloud concepts as well as how to use them, and the difficulty level is easy. Skills required for this certification is the different cloud computing concepts, main Azure services, describing Azure security, privacy, compliance, and trust, Azure pricing and support. And here are a few certification details required for the certification. Cost of examination is $99, which can vary. Average annual salary is $110,000. The duration of this examination is 85 minutes, and the number of questions varies between 40 to 60. And the type of questions are multiple choice and multiple response questions. The passing score for this examination is 70%, and the renewal time is 6 months. And the top companies hiring are Microsoft, Dell, Accenture, and Cognizant. Sixth is Microsoft Certified Azure Administrator Associate. An Azure administrator is in charge of deploying, monitoring, and managing Microsoft Azure solutions, which includes significant compute, storage, network, and security services. By earning this certification, you will be able to demonstrate that you can deploy and manage Azure compute resources. This certificate will prepare you to develop, administer, and monitor cloud services such as storage, security, and virtual environments, among other things, and the difficulty level is intermediate. So the skills needed for this certification is main Azure Services, describing Azure security, private, and compliance and trust, knowledge of Azure pricing and support, and knowledge of different cloud computing concepts. And here are the further important details needed for this certification. Cost of examination is $165 USD. Average annual salary is $107,683. Exam duration is 120 minutes, with number of questions varying between 40 to 60. And the type of questions are multiple choice and multiple response questions, with the passing score of 70%. Renewal time is 6 months, and the top companies hiring are Microsoft, Accenture, TCS, and Yahoo. Seventh is Google Associate Cloud Engineer. An Associate Cloud Engineer delivers and protects applications and infrastructure, oversees various projects, operations, and maintains corporate solutions to ensure that they fulfill performance goals. This person has worked with both public clouds and on-premises systems. For programmers, developers, and software engineers, this is the greatest Google Cloud certification. Its holder will be responsible for deploying web applications in the cloud, as well as monitoring and managing operations, and the difficulty level is intermediate. Here are some important skills required for you to excel this certification. Basic understanding of Google Cloud platforms, products, and services, and basic understanding of cloud concepts such as virtual machines, containers, and networking. And these are the few important certification details that you need to take care of. Cost of examination is $125 USD, with average annual salary of $109,415. Exam duration is 120 minutes, with number of questions 50. And the type of questions are multiple choice and multiple response questions, with a passing score of 70%. And the renewal time is 2 years. And the top companies hiring are Google, Goldman Sachs. Here comes the 8th one, that is Microsoft Certified Azure Solution Architecture Expert. To implement solutions, an Azure Solution Architect work with cloud administrators, cloud DBAs, and clients. This credential displays the ability to provide advice to stakeholders and translate business requirements into safe, scalable, and dependable solutions. This certificate is for experienced programmers, developers, and DevOps engineers who wish to become Azure professionals. This is the ideal cloud certification, and the difficulty level is hard. And these are the skills required for this advanced certification: deploying and configuring infrastructure, implementing workloads and security, creating and deploying apps, implementing authentication and securing data, developing for the cloud and for the Azure storage. And these are the details you need to remember. Cost of examination, $165 USD. Average annual salary, $135,000, with exam duration of 150 minutes. And number of questions varies between 40 to 60. Type of questions are multiple choice and multiple response questions, with a passing score of 70%. And the renewal time is 6 months. And the companies hiring are IBM, Microsoft, Infosys, and Medline. Coming to the 9th one is Google Professional Cloud Architect. A Google certified professional cloud architect means you demonstrate the ability to design and plan a cloud solution architecture, manage and provision the cloud solution infrastructure, design for security and compliance. The Professional Cloud Architect exam measures your abilities to design and plan a cloud solution architecture, manage and provision cloud solution infrastructure, and design for security and compliance. This is the ideal Google Cloud certification for experienced IT professionals interested in becoming solution architects for Google Cloud technologies such as Bigtable, BigQuery, and other GCP platform services. And the difficulty level is hard. And these are the skills you need to focus on. Proficiency with command line, Linux operating system and system operations, and 3+ years of industry experience. And here are the further details you need to take care of. Cost of examination is $200 USD with average annual salary of $140,000. The examination duration is 120 minutes with number of questions 40. The type of questions are multiple choice and multiple response questions with a passing score of 70%. And the renewal time is 2 years. And the companies hiring are Google and Goldman Sachs. And here comes the last but not the least, 10th certification, that is AWS Architect Professional. The AWS Certified Solutions Architect Professional exam verifies advanced technical knowledge and experience in designing distributed applications and systems on the Amazon Web Services platform. This certification aids in the identification and development of personnel with crucial capabilities for cloud implementation. The AWS Certified Solutions Architect credential verifies your ability to develop, implement, and evaluate applications on AWS under a variety of conditions. This advanced certification teaches you how to create and deploy scalable web applications on Amazon AWS servers, as well as how to choose the right service and power for your application. And the difficulty level is hard. And the skills required for this certification is familiarity with AWS CLI, AWS APIs, AWS CloudFormation templates, and Windows and Linux environments, ability to provide best practice guidance on the architectural design across multiple applications and projects of the enterprise, ability to evaluate cloud application requirements, and ability to design a hybrid architecture using key AWS technologies. And here are the details you need to know before applying for the exam. Cost of examination is $300 USD with average annual salary of $118,266. The examination duration is 180 minutes with number of questions 75. Types of questions are multiple choice and multiple response questions with the passing score of 70%. And the renewal time is 2 years. And the top companies hiring are Amazon, Accenture, IBM, and Mindtree. So this was all about top 10 cloud certification.
So if you are ready to embark on this exciting career path, look no further than Simplilearn's Caltech postgraduate program in cloud computing. This comprehensive program will equip you with the knowledge and skills needed to navigate the cloud landscape with confidence. Dive deep into cloud architecture, deployment models, security, and migration strategies. Explore platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform to build your cloud expertise. Don't miss out on this chance to transform your career and join the ranks of successful cloud professionals. Click the link in the description box below to discover more about the Cloud Computing Basics course. To know more about this course, click on the link mentioned in the description box below.
Let's have a look at some of the skills required to become a cloud administrator. First off, you need experience with programming languages like C# and .NET. You'll also need to be experienced with DevOps tools like Jenkins, Docker, Ansible, and Chef. You'll need to have an understanding of database configuration so that you can take advantage of all the relevant information about the hardware and software components used by the organization. You'll also need to have experience with cloud infrastructure systems like servers, storage, network, and visualization software. Finally, you'll also need to configure virtual machines, VPNs, and cloud servers. Now, let's have a look at the salary offered to cloud administrators. Now, in the United States, the average salary of a cloud administrator is approximately $65,000 per annum. Similarly, in India, it's approximately 7 lakh rupees per annum. Now, let's have a look at some of the companies hiring for cloud administrators. We have companies like Wipro, Infosys, Accenture, IBM, and so on. So here I see a comment which says, I'm a fresher and want to learn about AWS. How can I start? So actually, any fresher can make a career in AWS as long as you have interest towards the subject. Now, if you are from a non-technical background, you need to put in a lot more hard work and have a lot of patience. So I would recommend that before you take up the AWS course, you have a look at the course curriculum, types of AWS courses, opportunities in the market for AWS certified candidates, and so on. So now let's go to number 6, Cloud Application Developer. Now, a cloud application developer mainly focuses on implementing and maintaining an organization's cloud infrastructure. Now, they're involved with designing, building, creating, analyzing, and maintaining cloud systems. Now, these individuals are also involved with ensuring that there's an effective design of business processes in the cloud. They're also involved with a number of different tasks like optimizing efficiency and performance, scaling application components, and security issues. Now let's have a look at some of the skills required to become a cloud application developer. First off, you need to have experience with database languages like MySQL, SQL, and MongoDB. Then you need to have experience with programming languages like Python, Ruby, and Perl so that you can code and create cloud computing applications. You'll also need to have experience with Linux. Now this is because most cloud infrastructures are created with Linux servers. You'll also need to have experience with cloud service providers like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. You'll need to have experience with information security with the help of certifications. You'll also need to know how to create microservices and to create cloud applications. Now let's have a look at the salary offered to a cloud application developer. In the United States, it's approximately $70,000 per annum. In India, the average salary of a cloud application developer is approximately 8 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud application developers. You have companies like Bosch, McAfee, SAP, and so on. So now let's go to number 5, Cloud Network Engineer. A cloud network engineer is responsible for implementing, supporting, maintaining, and optimizing the network hardware, software, and communication links of the organization's cloud infrastructure. He or she basically focuses on automation and security while building the cloud infrastructure, enhancing network tooling visibility, and improving productivity. Now let's have a look at some of the skills required to become a cloud network engineer. First off, obviously, you need to have experience with networking, which means a familiarity with the internet and WAN communication technologies, protocols, and best practices. You need to have an understanding of cloud security and how you can design a public cloud with multiple options. You'll need to have an experience with data center administration, which basically means an understanding on infrastructure design, operations, and lifecycle management. And finally, you need to have experience with cloud computing platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Next, let's have a look at the salaries offered to a cloud network engineer. Firstly, the average salary for a cloud network engineer in the United States is approximately $72,000 per annum. In India, the average salary of a cloud network engineer is approximately 4 lakh rupees per annum. Now that we're done with this, let's have a look at the companies hiring cloud network engineers. We have companies like Amazon Web Services, Rakuten, Cisco, and so much more. Now for number 4, we have Cloud Automation Engineer. A cloud automation engineer focuses on cloud automation, orchestration, and integration. He or she implements, optimizes, and supports the cloud infrastructure and ensures it has high availability. They also have to increase the cost effectiveness and availability of the cloud. Now, let's have a look at some of the skills required to become a cloud automation engineer. First off, since the role is cloud-based, experience with a cloud service platform like Microsoft Azure, AWS, or Google Cloud Platform is an absolute must. You'll also need to have experience with programming languages like Python and Go that will help you make the process of automation easier. Next, experience with DevOps tools like Chef, Ansible, and Puppet are seen as a huge plus. You'll also need to have an understanding of Docker and containers. Experience with databases like PostgreSQL and MySQL that can handle multiple workloads would be very useful. And finally, you need to have experience with virtualization, which means you need to know how you can work with virtual servers, applications, storage, and networks. With this, you can reduce the amount of resources required by the organization. Now, let's have a look at the salary offered to cloud automation engineers. In the United States, the average salary of a cloud automation engineer is approximately $79,000 per annum. The average salary of a cloud automation engineer in India is approximately 5 lakh rupees per annum. Now that we're done, let's have a look at some of the companies hiring cloud automation engineers. We have companies like Oracle, Google, Capgemini, Disney, and so on. And now to number 3. Cloud Security Manager. A cloud security manager is someone who is responsible for providing security for cloud-based digital platforms and protecting the organization's data. He or she may be involved with creating new security methods or to analyze existing ones. They may also have to create cloud-based applications, performing threat simulations, and providing security recommendations. Now, let's have a look at some of the skills required to become a cloud security manager. First off, you'll need to have experience with at least one of the popular cloud service providers like Amazon Web Services, Microsoft Azure, and GCP. You'll also need to have experience in programming languages like Python, experience with commonly used DevOps tools like Jenkins so that you can implement continuous integration or continuous deployment models would be very helpful. You'll also need to be well versed with TCP/IP protocols and other networking concepts. You need to be well versed with PKI, SSL, SSH, HTTPS, and so on. Experience with web-based analytics and services would also be very helpful. Now let's have a look at the salary offered to a cloud security manager. In the United States, the average salary of a cloud security manager is approximately $99,000 per annum. In India, the average salary of a cloud security manager is approximately 11 lakh rupees per annum. Now let's have a look at some of the companies hiring cloud security managers. We have companies like Deloitte, VMware, Cisco, Dell, and so on. Now let's move on to number 2, cloud engineer. A cloud engineer is an individual who is responsible for any technological duties that are associated with cloud computing, including design, planning, management, maintenance, and support. They are also involved with orchestrating and automating cloud-based platforms throughout the organization. Let's have a look at the skills required to become a cloud engineer. First off, you'll need to have experience with at least one of the popular cloud service providers like AWS, Microsoft Azure, or the Google Cloud Platform. You'll need to have an understanding of networking concepts like building and accessing servers, virtual networks, and so on. This enables cloud engineers to make sure that the network is responsive to the users. Next, you need to have experience with virtualization. With virtualization, you can reduce how many hardware units you need with the help of virtual machines. It also makes resources scalable and fault tolerant in an organization. Experience with the Linux operating system would also be very helpful, considering how 30% of the servers that power Azure are Linux based. You'll need to know about APIs to design RESTful services. Experience with DevOps is also a major skill to have, since it'll be able to help handle work dependencies between the development and operation teams. And finally, you need to have programming experience with languages like Java, Python, C++, and Ruby. Next, let's have a look at the salary offered to a cloud engineer. In the United States, the average salary of a cloud engineer is approximately $105,000 per annum. The average salary in India is approximately 5 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud engineers. We have companies like McAfee, IBM, JP Morgan, Visa, and so on. Now, I see a pretty good question in the chat. How do you become a cloud engineer? So, to become a cloud engineer, you need to have experience with the programming language, experience with at least one cloud service platform, which is Amazon Web Services or Microsoft Azure or Google Cloud Platform. The choice is yours. And you need to specialize in a particular service, be it storage and networking, disaster recovery, and so on. And now for number 1, cloud architect. A cloud architect is responsible for managing cloud computing architecture in an organization. He or she handles everything to do with front-end platforms, servers, storage, delivery, and networks. Now, let's have a look at some of the skills required to become a cloud architect. First off, you need to have knowledge in programming. Knowledge about Perl, Python, Ruby, PHP, Java, and .NET can provide users with the ability to build, deploy, and manage applications quickly. You'll need to know about the basics of networking. Since most of the work what you'll be doing would be web related, knowledge about networking can be really helpful. Knowledge about data storage fundamentals are also really important. This provides you with the knowledge to determine which data storage option to use and when. Being experienced with cloud service platforms is also really important. Platforms like AWS, Google Cloud Platform, and Microsoft Azure are what you are going to be basing most of your work on. Experience with them is pretty important. And finally, cloud security. This will help you make sure that your data is secure and only authorized code is run and the right people are allowed to run it. Now, let's talk about the salary of a cloud architect. The average salary of a cloud architect is approximately $107,000 per annum. In India, the average salary of a cloud architect is approximately 16 lakh rupees per annum. And there you go. Those are the top job roles in the field of cloud computing. Now let's have a look at some of the companies hiring cloud architects. We have companies like EY, Wipro, Huawei, Hewlett-Packard Enterprise, and so on. And today I'm going to tell you how you can become a successful cloud computing engineer. Now, cloud computing is one of those technologies that's rapidly rising, and with any technology that's growing rapidly, it comes with several job opportunities for the people who are skilled in it. So before we get into it, let's have a brief look at what is cloud computing. Cloud computing refers to services like storage, databases, software, analytics, machine learning, artificial intelligence, and so much more, all of which made accessible via the internet. The cloud tech services market is expected to grow 17.3% in the span of 2018 to 19, which means there's a growth from $175.8 billion to a whopping $206 billion in 2019. And as of 2020, it's expected that 90% of all organizations in the world would be using cloud services. Not to mention, several organizations around the world suggest that using cloud computing services has enabled their employees to experiment a lot more with technologies like machine learning and artificial intelligence. So here's what we'll be going through today. Firstly, we'll be talking about who is a cloud computing engineer, the steps you need to take to become a cloud computing engineer, and the cloud computing engineer salaries. So first off, who is a cloud computing engineer? Now, a cloud computing engineer is an IT professional who takes care of all the technical aspects of cloud computing. Now, be it design, planning, maintenance, and support. Now, a cloud computing engineer can take up a number of different career paths. This could be that of a cloud developer, security engineer, a full stack developer, SysOps administrator, solutions architect, cloud architect, and so much more. Now, let's have a look at some of the major cloud computing roles. First off, we have solutions architect. Now, these are individuals who are responsible for analyzing the technical environment in which they are going to produce the solutions, the requirements, and the specifications. Secondly, they are required to select an appropriate technology that satisfies set requirements. They need to estimate and manage the usage and the operational costs of the solutions they provide, and they need to support project management as well as solution development. Next, we have SysOps administrators. They are involved in deploying, managing, and operating highly scalable and fault-tolerant systems. They need to select an appropriate service based on compute, security, or data requirements. They need to estimate and manage usage and operational costs, and they need to be able to migrate on-premises workloads onto an appropriate cloud computing platform. So among both of these roles, there are certain requirements that are remaining constant. Now let's have a look at the steps you need to take to become a cloud computing engineer. Your first step is to gain proficiency in a cloud computing platform. Now the first step is to become proficient in at least one of the three major cloud computing platforms, be it AWS, Azure, or the Google Cloud Platform. Now there are a huge number of resources that you can find on the internet. It could be YouTube videos, articles, virtual or physical classrooms, and so much more. Now after you're done learning, you can get certified by Microsoft Azure, AWS, or the Google Cloud Platform. Now for AWS, you have a number of different certifications which can be divided into three categories, which are the foundational, which is just the basics, the associate level certifications, the professional level certifications, and the specialty certifications. Similarly, with Microsoft Azure, you have certifications that enable you to become an Azure Developer Associate, an Azure Administrator Associate, an Azure Architect Professional, and a DevOps Engineer. Now, most cloud computing platforms have a free tier that you can take advantage of. These provide a number of free services for a period of time, some of which are free forever. So you can use these platforms to your advantage and do as much practice as you can on them. Now, if you want to learn more about cloud computing, you can also check out Simplilearn's YouTube channel. Then you can go on to the playlist section right here, and you can find comprehensive videos on a number of different cloud computing platforms, AWS and Microsoft Azure. Our AWS tutorial videos talk about what exactly is AWS, how you can become an AWS Solutions Architect, Amazon EC2, S3, some of the other services, and so much more. We also have detailed tutorials on Azure, which talks about what exactly is Azure, the certifications provided by Azure, some of the services like machine learning, Azure Active Directory, and so much more. And now we're at step 2, being experienced in at least one programming language. Unlike general purpose programming languages like C, C++, C#, and so on, cloud computing requires ones that are a lot more data oriented. Now, some of the major programming languages that are used in cloud computing are Go, Python, Clojure, and Java. Now, as I said before, there is a wealth of resources that you can learn from. There are free websites that you can practice your code on, like Quick Code, Code Academy, and several others. There's also resources like YouTube videos, as well as there's the option of online or offline classes. Now we're at step 3, specialization. You'll also need to be well versed with a number of key concepts. These are storage and networking. Now with storage, you need to know how data can be stored and where it can be accessed from. You need to know how it can be accessed from multiple different resources. You'll also need to have some experience with the services provided by Azure and AWS, like the Amazon S3 in AWS and the appropriately named Azure Storage from Microsoft Azure. With networking, you need to have a strong understanding of the networking fundamentals as well as virtual networks. Next up, we have virtualization and operating systems. With virtualization, you need to know how virtual networks, which are just a combination of different virtual machines, can be used to emulate different components in a particular system. With operating systems, you need to have a very strong understanding of operating systems like Windows and Linux. Next up, we have security and disaster recovery. Now you need to understand how data, application, as well as infrastructure can be protected from malicious attacks. With disaster recovery, you need to be prepared for any unexpected circumstance by making sure your systems are always safe and are regularly backed up to prevent any sort of loss of data. Then we have web services and DevOps. Now you need to have a strong understanding of APIs or application program interfaces and web services. Some amount of experience with web design also can be of great help. With DevOps, you need to have a strong understanding of how cloud computing is able to provide a centralized platform on which you can perform testing, deployment, and production for DevOps automation. Moreover, with DevOps, you understand the synergy that the operations as well as the development teams have with each other and for the success of any project. And finally, you're a cloud computing engineer. Now, let's have a look at the salaries of cloud computing engineers. In the United States, cloud computing engineers earn around $116,000 per annum. In India, a cloud computing engineer is paid approximately 6,66,000 rupees per annum. Now, how can Simplilearn help you become a cloud computing engineer? So let's head on to Simplilearn's website. Here we have the Cloud Architect Master's Program. Now this deals with a number of different courses, all of which that can help you get started in your journey to becoming a cloud computing engineer. This Master's Program covers a number of different courses like AWS Technical Essentials, Microsoft Azure Fundamentals, AWS Developer Associate, and so much more. It provides you 40 plus in-demand skills and 25 plus services, provides you a master's certification. It has 16 plus real-life projects and helps you get a salary that ranges between 15 to 25 lakh rupees per annum. It also covers a variety of tools like Amazon EC2, Azure Data Factory, virtual machines, and so much more. So why don't you head on to simplilearn.com and get started on your journey to getting certified and getting ahead.
Here we wrap up with the cloud computing basics. If you like this video, then hit the like button, consider subscribing to our channel, and hit the bell icon to never miss any updates from Simplilearn. Till then, keep watching and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.